Coisa, meus caras me desconectaram. Ainda bem que não aconteceu durante a live mais cedo. Do nada.
Good morning, good afternoon, and good evening, everybody. My name is Kartik. I'm one of the co-founders of ETH Global. I want to welcome all of you to the Polygon ZK Day. You are all watching this thing on ethglobal.tv, so just a quick reminder for everybody who's coming in for the first time. We encourage all of you to log in and say hi to all of us. This is the live platform we're going to be using for the rest of the day. And if you have any questions for our speakers, or if you have any comments that you want to relay to any of our audience or our speakers, you can write them in the chat there, and we'll be able to relay them directly to our speakers. And also for everybody who logs in, you will be getting a NFT POAP token, so stay tuned for that after the end of the summit. So this event is brought to you by ETH Global. And for those of you who don't know, ETH Global is an organization with a very simple goal. Our goal is to get more Web3 developers into this ecosystem. And we do this by running hackathons and summits. And this is our last event of the year, and we're super excited to be hosting this day, talking about all things ZK. So let's get into what today is going to look like. So we have an amazing day planned. We're going to talk about a handful of things. We're going to do a quick update on what is happening in the Polygon ecosystem and with respect to zero knowledge world. There's going to be an exciting announcement from the Polygon team, which I can't wait for everybody to also find out about. Then we're going to go into a few demos and talks on how Polygon Nightfall, Maiden, and Hermes are set up. So we're going to go into the polynomial identity language by the ZKVM team. And then lastly, we're going to have a panel discussion with all of our speakers and Vitalik Buterin to just cover what we can do to move this entire ecosystem forward. So without further ado, let's jump right in. I want to invite Sandeep, Jayanti, and Mihailo, the founders of Polygon, to come on stage and share some of their thoughts. And without further ado, let's bring all of them on to the screen. Welcome, everybody.
Thank you, Kartik.
Hello, everyone.
Everyone.
Hello,
Sandeep.
Do
we have Mihailo also?
Yes.
Awesome. So, yes, Mihailo, you're audible. So yeah, let's begin with a small intro, from all of us. So I'm Sandeep. I'm one of the co-founders at Polygon, and I look at the business side of things. That means the business development, marketing, and all the things related to this. JD.
Hi, Jayanti here, founder of Polygon. Started out of Matic here. Started tech and looking after the tech and research nowadays. Yeah.
Hello, everyone. I'm Mihailo, one of the co-founders of Polygon. I'm mainly interested in scaling in our research effort, strategic side of things, and thank you so much for attending this event in such a large number. We are very humbled and honored to see you guys here.
Yep, amazing. So let's start this event off with basically brief about the purpose of Polygon, and then we can move on to different things. We'll walk you through our timeline and about our ZK things and things like that. So but like the talk or the discussion about Polygon cannot start without the discussion of Ethereum, right? And this is so we wanted to discuss about first what is the core thesis of Polygon here, what exactly Polygon is trying to achieve here, right? So basically this whole Web3 space and what blockchains are trying to do is to provide basically this internet of value, right? Web 2 was internet of information, and Web 3 is basically internet of value. And our strong belief is that Ethereum has strongly emerged as the value settlement layer.
Essa Aztec que ele tá aqui no a Starkware, Optimism, Arbitrum e a Aztec, eu me baseei muito no conteúdo da Aztec para escrever o HEL, aquele protocolo de voto secreto em blockchain público.
So, but our belief is very strong that Ethereum is that settlement layer. And then on top of that, once
cara, olha o tamanho do ecossistema da Polygon. Você acha que isso é a Polygon? Olha o tamanho do ecossistema dos caras.
The layer 2 solutions or secondary layer solutions on top of Ethereum will be the avenues where the end users will interact, where the business activity will happen. But all of these different avenues will connect back into Ethereum, and that's the core thesis of Polygon, and it includes other ecosystem projects of Ethereum also.
Que chato, hein, Despa?
We want to truly be one of the most.
Tive maior pau aqui para conseguir botar a live de pé. Entrei até atrasado. Tô um minutinho atrás dos caras. Deu pau na Twitch.
And we say that, and you might have heard that debate of like.
Thales Andrade, bem-vindo aí.
It's this and that. First of all, like most of the people try, whenever they are talking about this, they are talking about one or the other solution of Polygon, right? But as a whole, what exactly is Polygon is that if you see.
What the hell is Polygon?
That Ethereum scaling is a spectrum. We don't believe in a narrow definition of layer 2. We believe that all the different kinds of different flavors of solution add value to Ethereum.
Cara, eles vão trabalhar com os shards do Ethereum 2.0 também.
So this is a spectrum that we believe that Ethereum scalability can happen, and you can see across the spectrum on the left extreme you see standalone chains where the security by Ethereum is very limited, and on the right extreme you see fully secured layer 2 chains which have both their data as well as dispute resolution, everything.
Pois é, Jeff. Olha o ecossistema que os caras montaram em volta, cara. Achando que muita gente acha que Polygon é só aquele blockchain onde está colocando os NFTs. Tem muita coisa
on the left extreme, you have Polygon SDK, which provides you
tarde Guiço, tarde RJ.
Sovereign chains.
Estão chegando
then
aí.
You have Polygon POS, which is like kind of in the middle. It is actually a chain, proof of stake chain built on top of Ethereum. And it is currently one of the most popular chains, and many of you guys might know that
vai pro YouTube depois,
Polygon solutions have the DAU even higher than currently the Ethereum main chain, and many of the users are using, and it's undoubtedly one of not the highest used platform globally right now. And then as I was talking about the spectrum, on the right spectrum you have the zero knowledge solutions, zero knowledge rollups, and EVM compatible rollups, which are being built by various different solutions, and then Polygon Avail as a data availability solution, which ETH 2.0 data shards also are going to be when it comes. They can give.
Imagina, né, Guiço?
So with that, with that base in mind, that what exactly is Polygon trying to achieve? Let's go.
Eu tô acostumado com o inglês indiano aqui, tem muito indiano por aqui.
Take us all through the journey of Polygon. And then move.
Eu lembro do fundamento da fundação da Matic.
So
olha que legal.
The idea to scale Ethereum in late 2017 when I was exploring multiple projects, and the same CryptoKitty happened at the same time, and then we realized that there is a need for the scaling solutions for the Ethereum, and at the same time we started coding about the Matic and founded Matic. Around 2018 we made it official. Sandeep, Anurag and I made it official that we are going to build Matic EVM based scaling solutions. At the time, like there were few scaling solutions, but they were so complex that the developers not going to use that properly, or if they use that, there won't be a tool after the production, after the mainnet, right? So we thought EVM based chain would be better suited here for the developers to use and move from Ethereum to that specific chain in 5 minutes or 10 minutes, simple, easy to migrate. And then we kind of did our IO in 2019.
Gente famoso de outro projeto que é o Matic. Eu não lembro não. Eu sei que o Vitalik vai estar aí hoje nesse bate-papo aí.
Multiple iterations, DevNet and testnet, we launched mainnet in early June of 2020, and since then we have been grown so well that top games onboarded end of 2020. In February, Mihailo joined in between late 2020. Mihailo joined as a co-founder. Polygon,
app.pitch.com.
Polygon with idea with a vision to have a multiple kind of solutions instead of one monolithic kind of POS chain solution.
Que é isso?
And you can see, like, you know, after 2021, Aave, major DeFi protocols as well came on Polygon, SushiSwap, Aave, and multiple others, right? In May 2021, Mark Cuban.
Não, Vitalik, cara, o Vitalik, ele tá defendendo isso, o uso de Zero Knowledge Rollups há tempos. Ele liberou um paper essa semana defendendo a escalabilidade através de Zero Knowledge Rollups para criar os blocos, mesmo que seja de um modo centralizado, mas que a validação é feita de modo descentralizado. E que esses rollups baseados em Zero Knowledge estejam no Ethereum. E a Polygon é quem está implementando isso primeiro. Então tem tudo a ver, eles estão extremamente alinhados.
EVM-based ZK rollups. We also launched 1 billion grant for 1 billion commitment from our side for the ZK-based.
E vai estar aí hoje no painel falando.
In Q3, EY came on board with Nightfall. With enterprises in mind and privacy in mind. And Q4 2021, we just announced, like a few days back, we announced Polygon Miden, with start-based EVM solutions, ZK solutions. And one more thing, we are going to do that, but after some time. Wait for that. Yeah, you too, Mihailo.
Thanks, JD, and thanks, Sandeep. Yeah, so let me briefly cover what we call the Polygon ZK thesis here. And this thesis, basically the blog that covers it in more depth, is published several months ago. And basically we keep publishing it with every ZK related announcement. And I guess we can share it also after the event or during. But let's just briefly cover it. And one of the things that are part of this, some of the things that are part of this ZK thesis are relevant to what Sandeep and JD said. So I'll just try to run through these things as quickly as I can.
Ele falando e eu entrando na plataforma pitch.com porque tem que fazer pitch o tempo todo. E aí eu fui ver o que era a plataforma. A plataforma só para fazer pitch. Se você precisa fazer apresentações, é tipo um facilitador de criação de PowerPoint.
This whole promise of this
Tarde, Kiko.
Global permissionless Internet of Value is really amazing and really supposed to complement this Internet of Information that we have been creating for the past decades and create a huge value add basically for the humanity, if you will. And we are fascinated by that idea, and we decided to pursue it and commit all of our resources to help reach that amazing and grand vision. That being said, again, Ethereum is Web3, equals Web3 in our minds, but we need to scale it first of all. So let us first cover where Polygon was, like Polygon beginnings and Polygon where it is now, basically, and the wider context of the industry, I guess, when we started versus where we are now. So when we started, as I said, there was this pressing need to scale. The Ethereum mainnet was heavily congested. Ethereum user base started to kind of deteriorate in a sense that alternative chains started popping up with some normally trade-offs.
A diferença da Polygon para as outras soluções de Layer 2, comparando com Arbitrum, Optimistic Rollups ou mesmo ZK Rollups, é que a Polygon é uma sidechain. Ela tem uma moeda própria, tem um blockchain próprio, né? E trabalha ancorando as suas transações no blockchain do Ethereum. Então ela é uma sidechain. Comparativamente com a Arbitrum é um conjunto de smart contracts que rodam no Ethereum, uma plataforma que trabalha off-chain, e na Arbitrum você utiliza o próprio Ether. Então a Arbitrum está mais para uma Lightning Network, que está ancorada direto no Bitcoin, e você usa Bitcoin dentro dela, né? No caso da Polygon e outras soluções como Polkadot e tal, elas têm uma moeda própria. É uma sidechain que ancora as suas transações no blockchain do Ethereum. Mas é um blockchain completo, com um ecossistema completo ao entorno dela. Essas são as principais diferenças.
And security, first of all. On top of it, we have EVM as the standard that is kind of already established. All these things or requirements combined together make it pretty challenging to build kind of perfect or ideal solution or solutions. On top of that, Polygon, when we started, we have really modest resources.
Eles estão fazendo toda aquela intro, né, de como que é a Polygon, a estrutura, tudo dos caras, né?
And even though the treasury was managed really well, we still basically, because market cap was very low, we had
Despa, não consegui entender.
at our disposal. And where we are now, like 10 months later, I guess, or so.
Não sei se é legal botar uma funcionária dentro da Matic. Eu não sei, cara, o que você está querendo dizer aí. Eu acho isso estranho. Esquisito você, Despa.
Apart from Ethereum, we are very likely, to the best of our knowledge, the most adopted blockchain network or platform in the world, apart from Ethereum, which is, I guess we all agree, a huge success in such a short period of time. One additional thing that significantly changed since then is
Estamos acompanhando, Rodrigo. Vamos acompanhar o lançamento aqui das Zero Knowledge Proofs na Polygon. É uma baita de uma novidade, cara. Isso aqui vai pro Ethereum logo mais. A gente está conseguindo assistir aqui, saber desse lançamento antes. Vamos ver o que vai ser o futuro aí dos blockchains. E na Polygon ainda.
And still capture value and still add value back to Ethereum instead of competing kind of with Ethereum.
Esse começo tem bastante blá blá blá, né?
Maybe set an example for future founders to think about when they're starting their projects. As a consequence, I guess, of this high level of adoption that we have seen. So we right now have more than 3,000 applications deployed on Polygon. We have more than 100 million.
Eu penso em escalar a Original Mais para Polygon também. Para a gente faz todo sentido.
Even now in user funds, completely organic, without any incentives from our side. This huge level of adoption has subsequently led to the growth of the price of the token. We're not here to talk about the price, of course, but I'm just saying that subsequently increased dramatically financial resources that we have at our disposal. And that, of course, put us in a much better position for what we are about to do in the next chapter of Polygon. And now we can, Sandeep, if you can go to the next slide, please, so we can actually get to the thing. So how did we achieve? How did we achieve this success and this growth in such a short period? We had a clear understanding, and we still have, that we have two major focuses that are driving everything we do at Polygon. One is shipping, and the second one is innovation. Innovation, because we are still in very early stage when it comes to building infrastructure for Web3 and this Internet of Values. So right now on Ethereum, we have millions of users, but we really want to onboard 1 billion plus or even the whole world, and which means we need to scale 1000x from this point without, again, as I said, sacrificing this major principles, major design or engineering principles of Ethereum. To do that, a lot of innovation, it still has to be done. A lot of work on that front is ahead of us, and we understood it, and we are willing to accept it as one of our focuses. And the other one is shipping. For us, we're all, I guess, engineers by education and training, and we are shipping oriented. And for us, unfortunately, innovation without shipping is just an academic, basically, exercise. So yes, starting from there and realizing this pressing need to scale, we realized that we, for now at least, have to be very focused on shipping in this first period. As JD mentioned, we delivered Polygon POS, which turned out to be a huge success. We intentionally offered it as a solution that has certain trade-offs. No, not a single solution is perfect, of course, but we just realized that the community really needs solution today, EVM compatible solution today without any delays. That was a very good decision in hindsight. And after all this growth and considering where we are now, which I just covered, we believe at Polygon now we need to focus even more and commit. We are in a great position to commit much more resources, all sorts of resources, financial, human resources, etc., to innovation. I think something happened with the slides. If we can just go back maybe to where we were. So yes, we are focusing back on innovation without losing focus on shipping. Shipping is still one of our, of course, major focuses, but we just believe that we are now in a very good position and we are thankful for that. And we want to commit significant resources basically to the innovation activity happening on Polygon. If you can just get back the slides, that would be great. I think something happened. Just a moment, I apologize.
Just give me 1 sec. There seems to be some issue with my this one's. Yes. Okay. Sorry for this disruption, guys. Okay, are we back? Guys, can you see my screen?
Yes.
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 Okay. Okay, awesome. Mihailo, you can proceed.
Just a moment. I try to open the presentation myself. Okay. Yes, excellent. Okay, sorry for this, guys. Okay, so speaking of innovation and our focus now on it, there are, as many of you will know, there are basically two major families of innovative solutions built on top of Ethereum, which are commonly called layer 2 solutions. One group are fraud-proof based solutions, which are the most prominent ones currently, at least, are optimistic rollups, and Plasma is also part of that same family of solutions. The other one are the second group are ZK-based solutions. As JD said, like we all started researching and experimenting with these solutions pretty early in 2017, I guess, ever since Plasma was introduced, and that's basically how JD and I met in the first place. And throughout all this time, we analyzed all these solutions, and we came basically to a conclusion that ZK-based solutions are probably the I don't want to say the way to go, but we definitely became biased towards this family of solutions because of several major reasons. We don't have, I guess, the capacity or the time to go into all the details and compare these two families.
Vocês não sabem, eu tô envolvido. Brincadeira, galera, brincadeira, não tô não.
Scaling, first of all, in terms of security, first of all, formal security, provable security, and in terms of user experience. And these three things are, as we
O bloco verso, Rodrigo, o bloco verso.
Critically important when building scaling solutions. That's why we decided that ZK basically is a strategic resource for us moving forward, and that we want to.
É legal que vai ser uma aula essa apresentação aí sobre Zero Knowledge Proof.
Our treasury to experiment with these exciting solutions. So ZKPs, or zero knowledge proofs, or zero knowledge cryptography, is basically, I would say, a fascinating field of cryptography. It was introduced in mid-80s, and it didn't really have a lot of applications until blockchains came by. Zero knowledge cryptography, uses very interesting cryptography primitives and methods to prove certain statements, normally without revealing.
E o governo do Canadá dizendo que as tecnologias de criptografia são muito novas. Tá falando aqui, ó, anos 80 criados Zero Knowledge Proofs.
Huge amount of computation or large amount of statements or transactions, if you will, and it became obvious along the way when blockchains were introduced and when the scaling pressing need to scale was became obvious.
São as minhas aulas de teatro.
Became also kind of obvious that ZK and their special properties might be a really, really interesting tool, basically, to address these major challenges. That's why we have seen in the past, I guess, 2 years, we have seen a true Cambrian explosion of innovation in the ZK field, a lot of new protocols, a lot of new primitives, a lot of new projects, and we are very happy to see that, and we are even more happy to be able now to seriously join this evolution, basically, of ZKs. As I said, we decided ZKPs are a strategic resource for us, and we decided to support this effort and innovation in this field with 1 billion fund or 1 billion commitment from our treasury. If we can just go to the next slide. Okay. And I want to just briefly cover what we have done so far before I hand it over.
Fundo de só $1 bilhão para desenvolver as ferramentas de Zero Knowledge Proofs. Devs disponíveis aí.
And in the
Oportunidades,
meantime, we are very proud and happy that we have already significant results from this commitment. And so far, we have 3 active projects, 3 very exciting projects under the Polygon umbrella. First one is Polygon Hermes, as JD mentioned. It is basically EVM compatible rollup. One interesting thing or let's say 2 interesting things about Hermes out of many are that Hermes is the first decentralized rollup. So rollups are currently normally centralized in a sense they normally have centralized operator. Hermes team has built the first and only, to the best of our knowledge at this moment, decentralized rollup. And they are now building ZK EVM, which is basically the reimplementation of the Ethereum virtual machine in a ZK-friendly manner, so to say.
Cara, olha o que ele acabou de falar. Eles estão redesenvolvendo a Ethereum Virtual Machine, o cliente do Ethereum, para lidar com Zero Knowledge Proofs. Não é só Smart Contract, não. E plataforma off-chain. Eles desenvolveram um novo cliente para a plataforma para ler Zero Knowledge Proofs.
Hybrid rollup, basically, which is a hybrid of optimistic and ZK rollup, which is privacy focused. So this is the first application.
Monero não usa Zero Knowledge não, Giovanni.
ZKs targeted towards privacy. So that's the main reason, I guess.
Mina usa, Zcash usa.
The third one that we have announced so far is Polygon Maiden. Polygon Maiden
is a Pirate Chain usa Zero Knowledge Proofs. Monero não usa não. Monero usa blind ring signatures,
which is going to be Ethereum compatible. So in a sense, you can draw some parallels, I guess, with Starkware effort between these projects, with the difference that this project is fully open source. It's mainly community driven. And there are some, of course, differences in the architecture, which we find very interesting, but we don't really have the time to cover those differences now. What is very important for us, like critically important, that as you can see, there are already 3 projects here. And some might ask, okay, how will these projects interact? Will they be competing with each other? What is your idea there? For us, we are extremely happy that we managed to establish a really, really good atmosphere between these projects. We are all aware that this is, again, a very early stage of innovation. These projects are working very closely together. They're constantly in touch. I mean, we are all constantly in touch. We are exchanging knowledge, updating each other, helping each other, and we are moving together towards this hopefully brighter future of scaling. That being said, this arsenal is already very powerful, I would say. But it might even be better, or might even complete the puzzle if we just can add something more to it. So what can we possibly add? I will leave it now to Sandeep, but can we imagine that we have the fastest ZK scaling technology in the world? That in some way would probably
eles querem a mais rápida ZK scaling, porque ZK não é rápido. Precisa de muito poder computacional para gerar as provas.
Sandeep, please.
Yep. Karthik, you want to bring up your part of the presentation for the announcement? At least the placeholder. So yeah, I mean, guys, while Karthik is bringing that up, so basically, as Mihailo mentioned about our Polygon, ZK thesis, that and why we feel that the announcement that we are going to do today is very very big is that there are
Cadê o announcement?
a few ZK solutions out there, but one of the biggest problems with ZK solutions have been always about performance, and the second thing is that because it requires a large amount of resources for ZK provers to create ZK proofs. It makes it essentially very hard to decentralize, right? So imagine, like as Mihailo was saying, that if we had a very extremely fast, probably world's fastest ZK recursive proving technology, and extremely efficient also, which could run there, where you could run ZK proofs on a simple machine like a laptop. That would be the game changer for this industry, where a large number of nodes can be run in a network, which can validate the transactions and things like that, which will actually truly make us or truly enable us to create decentralized layer 2 network for Polygon. And like for that, I'm extremely happy to announce on behalf of our entire team, everybody, is that Polygon has Polygon is very excited to welcome Polygon excited to welcome Polygon 0, which will be led by a really brilliant team of cryptographers and engineers, primarily Brandon and Daniel, and they were previously doing it as Mir protocol, which has now decided to join Polygon and focus on ZK scaling. Previously, they were building like a ZK enabled chain, but now they have decided to join Polygon and build a decentralized ZK rollup on top of Polygon. So with that, I will request Brandon and Daniel to take the stage.
Estão montando time, olha lá, Polygon 0, cara.
Community, like we are extremely happy.
Time só focado
this essentially now
em ZK rollups.
This entire ZK scaling effort. We truly believe that ZK is going to be is the ultimate frontier.
Entraram os dois, esse tal desse Brandon e esse Daniel Lubarov.
And this with me team also joining already an amazing suite of solutions on Polygon. This puts Polygon in the lead globally in terms of the ZK solution providers. So over to you, Brandon and Daniel.
Hey everyone, I'm Brendan. I'm the one of the co-founders of Mir. You may not have heard of us, but hopefully we can give some detail on what we've been working on. And so I'd just like to say that
tá com o celular conectado no microfone, mano.
Obviously, Polygon has had incredible success in attracting users and developers. But I think what's really impressed us is their vision for the future and their commitment to ZK scaling. And so over the past few months, we've had the privilege of working with Hermes and with Maiden, and it's already been a really fruitful collaboration. And we're really, really excited to be Polygon 0. I think on behalf of me and Daniel, we're also really, really excited to be coming back to the Ethereum community. Ethereum is how we both got into crypto in the first place, and it's a privilege to work alongside so many great teams to scale Ethereum. So I'm going to give a little overview of what we've been working on, and then I'm going to hand it over to Daniel and some of our team members to give a little bit more technical detail. But I'd like to open with this. So in the history of computing, there's this thing that happens, which is when you increase computing speed by 10x, you unlock radically new applications. So this has been true across platforms. So for the PC, for gaming, for mobile, every time you deliver processors that are 10x faster, the space of things that you can build and the possibilities increases dramatically. And so I guess from that perspective, we view ZKPs is sort of a new computing platform. And we'd like to pose a question to the Ethereum community, which is, what can you do with ZKPs that are 100x faster? Specifically, recursive ZKPs that will allow us to build things like more decentralized rollups, new ways to provide privacy to users.
Okay, mano.
So we're just going to talk a little bit about how we've done this, what we mean by recursive zero-knowledge proofs, and sort of go from there.
Nós aumentarem 100 vezes a velocidade com ZK.
Recursion is really important for scalable ZK rollups because, as we know, the premise behind a ZK rollup is that we can take a large number of transactions that would be too expensive to verify on the Ethereum main chain, and instead we can process them off-chain and generate a succinct proof.
A parte mais importante é que não tem front running, não tem MEV nas DEX, cara. Porque é zero knowledge.
Transaction throughput while still maintaining
é maravilhoso.
The properties that we love about Ethereum, that it's decentralized and it's secure.
Acaba com a festa.
The issue with ZK rollups right now is that it's actually
fora a velocidade
to generate a proof showing that a large number of transactions are valid. This is especially true for ZK rollups that support general applications and even more so for
o que é lindo do ZK Rollups é que você pode fazer uma prova de provas e essa última prova confirma a autenticidade de todas as provas anteriores, matematicamente. Porque como ele usa polinômios, é uma curva, ele vira pontos na curva. Então a prova é menor e você consegue acumular inúmeras provas em uma única prova. É lindo. Não é que nem uma Merkle Tree normal de SHA-256 que você precisa ter toda a árvore. Embora ela confirme, se você pegar uma outra prova anterior, a prova mais recente não comprova ela. Você tem que pegar toda a árvore que vai se comprovando e você verifica a autenticidade de tudo, mas você tem que pegar toda a árvore no Merkle Tree tradicional. Com ZK e as V-Merkle Trees, isso acaba. Uma prova de provas valida tudo anteriormente. Uma única prova. Tem que seguir o caminho desse. Na Merkle Tree tradicional. 2019, exatamente o tempo de 2018 para 2019 que eu levava para fazer uma prova, ficava na casa aí de 2, 3 minutos para gerar uma prova. Quando eu fiz o Hell. Quando eu escrevi o Hell no final de 2018.
So in 2020, two things happened. So the brilliant team at Aztec developed the first
no paper do Vitalik, no blog, não foi um paper, mas foi um blog post, ele fala da Plonk. Vamos ver se eles vão aprofundar. 15 segundos, mano. Mais de 2 minutos. É que ele botou 2, mas ele foi bonzinho, porque fica entre 2 e 3. Para 15 segundos, meu amigo.
And it allowed us to achieve 15-second proving times. But the problem was that this wasn't Ethereum compatible, so we couldn't use these faster provers on Ethereum. And so now I guess we're really happy to announce Plonky 2, which is a new proving system based on Plonk, Fry, and some wizardry from our own team. And so I think it's really important to sort of give credit where credit's due.
Tá de brincadeira.
This advance is based a lot on really brilliant work from Zach and Ariel at Aztec, who developed Plonk, and then
esses caras da Aztec são demais. São demais.
And so this represents a 100x speed up for recursive proofs on Ethereum. So Plonky 2 is fully transparent. There's no trusted setup.
É ZK Stark, não precisa de um setup confiável.
About 1 million gas to verify a Plonky 2 proof. And this is constant. Like we could have a recursive proof that verifies 1 million transactions. It still only costs 1 million gas to verify on Ethereum.
É que eu falei que uma prova confirma todas as provas anteriores. Então, uma única prova, mesmo sendo muito cara para registrar, ela confirma 1 milhão de transações anteriores.
Now we're measuring recursive proof generation time not in seconds, but in milliseconds. And so
a gente está falando de um lançamento de um novo protocolo de escalabilidade. É extremamente técnico, tá, Rodrigo? Mas é um protocolo de escalabilidade para o Ethereum, para Polygon. 170 milissegundos para fazer as provas recursivas do MacBook Pro, cara. Isso é inacreditável. De verdade. Eu quero pôr a mão nisso aí.
Show this. We'll see on Zoom if it slows.
Tá gerando circuito? Já gerou a prova? Você tá zoando. 0.3 segundos para gerar a prova. Mano. Para vocês terem ideia, num sistema de voto, numa eleição de escala como o Brasil, você vai gerar uma prova de todos os votos, de todas as provas dos votos, cara. Que comprova todos os votos que aconteceram sem exibir o voto de ninguém. Você pode ter 200 milhões de votos em uma única prova, confirmando todos os votos de todo mundo. Numa velocidade assim, que era um problema. Que eu, inclusive, no meu paper, eu endereço o problema de computação para gerar as provas. Isso aqui agora vai dar para gerar no celular. Numa boa. Para voto, isso aqui é simplesmente sensacional. Eu não tava com... Mano, isso é lindo. Olha lá que eu falei, os caras estão desenvolvendo uma máquina virtual do Ethereum baseada em ZK Proofs, cara. É um nó só para lidar com Zero Knowledge Proofs. Então não é só escalabilidade, é privacidade envolvida ainda por cima. São os dois, escala e privacidade.
Generating these proofs can be very expensive, especially if we're proving something like an EVM program.
Gerar snarks é caro, que é o que eu estava fazendo no Hell.
So it has features like arbitrary control flow, random access, and all kinds of binary arithmetic. These aren't features that are natively supported by Snark primitives. We can simulate them, but there's quite a bit of overhead. So on the right here, I took this benchmark from one of the old TinyRAM papers. TinyRAM is this virtual machine that we can prove the execution of. And the authors measured basically the simulated clock rate of this VM. And as you can see, it took about 33 seconds just to prove.
Isso aí pode ser implementado no Ethereum muito em breve, Rodrigo. Esse que é o ponto. Está sendo implementado primeiro na Polygon. E para o Ethereum, depois que estiver bem estruturado, bem implementado, é um pulo. É tecnologia que vai chegar no Ethereum muito em breve. Isso aí deixa os optimistic rollups que acabaram de lançar Arbitrum, acabaram de lançar Optimism, deixa os caras obsoletos. Tudo que a gente viu de Arbitrum até agora pode considerar obsoleto. Com 4 threads, mano.
So when we started this project, we wanted to collect some real data about what sort of computations we're dealing with. So we spun up an Ethereum node and we recorded a bunch of blocks and we looked at basically what's going on in terms of, for example, we found that the average transaction executes.
Aqui ele está entrando no assembler, no código de máquina, que é o que acontece para o Ethereum, para a máquina virtual do Ethereum interpretar uma transação.
So, for example, we have the average transaction executes 88 of these AND instructions. This is a bitwise AND involving 256 bits.
Esses dias a Miriam viu que eu ficando louco fazendo, auditando smart contracts em assembler dias atrás. Nossa.
Or we can use lookup tables or other techniques. but there's still a lot of overhead either way. The other thing that concerned us a bit here is this SHA-3 instruction. The SHA-3 is this catch-ACK hash, and it involves hundreds of thousands of bit operations just to evaluate a single hash, and the average transaction does 13 of them. So this might sound pretty negative so far, but it's okay. We can still make this fast. We just have to be incredibly focused on performance. So with that in mind, let's look at some of the proof schemes that we could consider using. We basically considered three options. The first is schemes based on KZG, like Plonk. And KZG is this polynomial commitment scheme based on pairings. It has some nice properties. It has very small opening proofs, so a whole argument can be less than a kilobyte. It's easy to verify on Ethereum. However, the challenge here is that it's hard to do recursion with pairings. There are a few different approaches here, but none of the results look really good for performance. So next we considered these schemes based on Halo. Halo is this idea that came out a couple of years ago, and it provides this really clever way to do recursive proofs without pairings using elliptic curves that are not pairing friendly. And we actually implemented this, as Brendan mentioned, in our library, Plonky.
Hey, Mamba.
And we were able to get decent prover speed and a decent recursion threshold this way. But the problem, as Brendan mentioned, is that Halo takes linear time to verify. So it just really isn't practical to verify on Ethereum unless we combine this with other techniques. And finally, we have schemes based on Fry, like Starks. And these are particularly
ZK Starks, não Snarks, mas os Starks, que não precisa do setup confiável.
It really depends on the settings that we use them with.
Utilizando esse Plonk tool que eles estão desenvolvendo, aumenta absurdamente a velocidade de verificação e o custo reduz exponencialmente comparado com os outros. Incrível o que esses caras estão fazendo. Incrível.
A small blow factor, which means less redundancy, so we have less data that we're committing to, and proving will be faster. However, the caveat here is that a smaller blow factor reduces the security of the Fry protocol, and we have to compensate for this by running more queries, and this increases proof size. So we have this dilemma where we can either choose a fast prover or small proofs, but we can't really have both at the same time. Luckily, recursion helps us here. So with recursion, we can take a larger proof and we can shrink it.
Uma maneira, Hitman, de repente se envolver com os códigos dos caras e começar a entender o que está acontecendo. Acabaram de lançar Polygon 0, acabaram de lançar. Vai ter um monte de código bugado lá para debugar e para resolver. Talvez esse seja um ótimo meio. Entender sobre Zero Knowledge Proofs, Snarks e Starks, que Starks é o sucessor dos Snarks. A Zcash é baseada em Snarks e já está obsoleta, já há um tempo, né? Em relação aos Starks, o problema é que o Stark não está implementado ainda. E agora começam a surgir as implementações com os ZK Starks, com outras técnicas e protocolos que deixam mais rápido ainda.
So before sending a proof to Ethereum, we apply the same technique, but
eu acho que para entrar nessa história dos smart contracts, começa vendo NFT, começa vendo tokens, DAOs, e aí daí para diante. Mas o começo de tudo é olhar como que funciona o sistema de governança em blockchain. Uma DAOzinha é simples, um token, um NFT, um sistema de voto baseado em DAO. É um bom começo e é fácil. É tipo a base do negócio. Exatamente, a multiplicação de números de 256 bits é cara. É muito cara. Ele encoda o witness em 64 bits, cara. É muito pequeno.
One is that the Fry protocol assumes a larger field of at least 100 something bits. So here we borrow this idea from ETH-Stark, which is we encode the witness in a small field, and then when we run the FRI protocol,
E ele ainda faz a verificação diversas vezes.
64-bit field. And that way we can get the
Será
same
que
security of
precisa?
having a larger field. It's just
Você
not a
perde
time field,
performance,
but
né, se
that's
você
fine. FRI
repetir a
doesn't require
verificação
that.
várias vezes, mas precisa para
There are also
segurança.
a couple of complications with the Plonk protocol, where in certain places Plonk assumes a larger field for security. So we could apply the same technique and run those protocols in this extension field. In some cases we do that, but in other cases we use another workaround, which is to keep using the small field, but we repeat some of the checks in the Plonk protocol in order to boost soundness. And that's it for
Nossa,
me.
otimização de circuito, cara. Essa é a parte mais dura para gerar a prova.
So yeah, I'll talk about the recursive circuit optimizations we use in Plonky 2. So first, a quick intro on proof recursion. The basic idea is that in a proof system, we have both a prover and a verifier. And for proof recursion, what we do is we write the verifier inside a circuit, and that allows us to verify a proof inside another proof. Okay, this sounds easy, but historically it's been a really hard problem to design efficient recursive proof systems. Okay? And recently there's been some research on that, in particular on accumulation schemes with Halo, but those have many drawbacks, as we saw in terms of performance. Okay? And so our solution to this problem is to use Plonk with a FRI-based polynomial commitment. But now, if you try to write naively the verifier in a circuit, you'll end up with quite a large circuit with 2 to the 16 gates, so around 60,000 gates, which is okay, but the prover is a bit slow, so around 10 seconds. And so we really focused on bringing
Bastante, né? 2 elevado a 16 gates.
So first, a quick recap on Plonk. So in Plonk, you have a table of field elements. And on each row of the table, you have a polynomial constraint that evaluates to 0. Okay? And each row can have different constraints. And so if you go and look at the original Plonk paper, you'll see that they use a table of which 3, so only 3 columns. Okay? And
eu posso aumentar um pouquinho, pouco.
Between 10 and 20 columns. But we decided to use a much wider table with a width of 135. Okay? And this may sound like a lot at first, but the design of our system is so that it's really okay. For example, we can commit to all the columns with just one Merkle root. Okay? With other polynomial commitments, you would have to commit to each column individually, which would be terrible for performance. But we can just do it with one Merkle root. But so why do we need such a wide table? Is to design complex gates. Okay. So, for example, in the FRI verifier, there's this complex operation, which is interpolation. So we have 8 pairs of points, x0, y0 to x7, y7, and another point z. And we have to interpolate a polynomial of degree 7 on these pairs and evaluate it at z. Okay, so that's quite a complex operation that would take a lot of gates if we did it with classic Plonk. But with our white table, we can actually do it in one gate. Okay? So how do we do so? We start by finding the interpolation polynomial f outside the circuit, and then we evaluate it at z to get a value v. And
é mais simples do que parece, tá?
In a single row, as you can see on the bottom right. And then we have a bunch of constraints on this row. The first set of constraints checks that f is indeed the interpolation polynomial of the pairs. And then we add a constraint to check that f of z equals v.
Tá.
Okay.
Ele tá explicando, essa parte ela é técnica, mas quando a gente vai desenvolver, a gente vai usar a biblioteca que vai fazer tudo isso pra gente, tá?
Uses a lot of hashes. Like currently, they make up 75% of the circuit. So it's crucial to us to have hashing as efficient as possible inside the circuit. And we decided to use Poseidon, which is an algebraic hash.
É difícil explicar em cima do que o cara está falando. Tem aquela matriz. Normalmente numa Merkle Tree a gente vai fazer o hash de cada coluna e fazer no final um hash do hash das colunas. Tá? Como você tem que fazer o hash de cada coluna, é muito caro o processo. Nesse caso aí, quando você fala ela faz uma verificação polinomial, você vai rechear as linhas. É como se fossem hashes das linhas, mas é um cálculo matemático, não é um hash pelo hash em si. É um cálculo matemático.
And then we used our white table to write complex gate to do these operations. One other nice optimization we use is
aqui, ó. Aqui fica mais fácil entender.
So the Free Verifier does a lot of Merkle proof verifications. So on the left here, you have a classic Merkle proof verification. So you start at a leaf, and then you hash your node with its siblings until you go
você faz o hash do hash de cada um do filho, do hash, né? Para chegar lá no resultado. Olha o que você diminui. Você quebrou, você tirou aquela segunda coluna, ela diminuiu e se juntou com a primeira coluna, não, a primeira linha, né? Então você tirou aquele primeiro layer, juntou com o segundo layer, porque você somou. É porque o Zero Knowledge Proofs, que é uma prova de provas, ela consegue autenticar todas as provas feitas anteriormente. Não é diretamente pegar um booleano e transformar num inteiro. Até porque a gente usa muito booleano. Mas é encontrar pontos numa curva. Basicamente, ele vai gerar uma equação e vai colocar todas as respostas daquela equação numa curva. Então, quando você olhar para aquele resultado, você só vê se ele é um ponto naquela curva. Se você transformar aquilo num ponto e ele bater no ponto da curva, um ou mais pontos da curva, porque tem que ser uma curva, tem que ser mais de um ponto, né? No mínimo 3. Se não, com 2 pontos numa curva, você não gera uma curva, gera uma reta. Você consegue validar. Por isso que o circuito dele tem 2 elevado a 12, não 16. Porra, cara, é muito otimizado. 2 elevado a 12 é muito menor que 2 elevado a 16. É muito menor.
And now I'll let Jacob talk about low-level optimizations.
Alrighty. So let's talk about speed. We talked about high-level optimizations.
Vou soltar meu cabelo também.
We talked about optimizations to the circuits. Now let's talk about how we implement the very lowest level things. I'm talking like multiplication really, really fast. How do you make math fast? To make math fast, you need both mathematical insight and technical expertise. An engineer can take a spec and write code that runs really, really fast on whatever hardware you're using. An excellent mathematician can take whatever work needs to be done and minimize the number of
já tá querendo demais, né? Olha lá, a produção aqui tá... Olha a produção aí,
finite field multiplication is fundamental mathematically, not physically. There is no logic gate for finite field multiplication. So the mathematician only really sees a proxy. On the other hand, for the engineer, the spec is immutable. There's only so far that software engineering tricks can take you, and a spec can only run so fast. To make math fast, you need to flip the causation, right? The work that you're doing needs to be determined by the physical reality of the hardware that you are doing it on. Plonky 2 is built for performance, right? When we were designing the protocol, we were already thinking about how fast it would be running on commodity hardware. The earliest of decisions in Plonky 2 were already guided by performance. Let me give you an example.
Outro conselho para quem perguntou, né, como entrar nesse mundo, pegar o nome desses caras e seguir esses caras no Twitter agora.
What's a good choice for P? That's a very fundamental question. Well, firstly, it needs to fit within 64 bits, like Daniel's already mentioned. And the reason why is that modern computers are 64-bit machines. And once you've crossed the 64-bit boundary, everything suddenly gets so much more expensive. but it also can't be much smaller than 64 bits for security reasons. So you want it to be almost 64 bits, but not quite. And different choices of P will also have different algorithms for multiplication and addition with different performance characteristics. So we want to choose P such that multiplication and addition, those fundamental operations, are really fast. So we went through a lot of candidates. Here's a GitHub thread where we documented our research. We considered many fields, each one with their own algorithms for arithmetic operations. We derived those algorithms. We examined the compiled assembly code. We counted cycles and micro-ops. And what we ended up settling on is this really neat prime number that has a frankly beautiful mathematical structure that just happens to play really well with how modern CPUs and ISAs
eles estão gerando primos. Olha o cálculo de primos que ele está fazendo.
As Williams already mentioned, we spend a lot of time doing hashing, and the hashing algorithm we use is called Poseidon. Within Poseidon,
engraçado, ele gera um primo de... Ele gera um número de 2 elevado a 64, menos um 2 elevado a 32, mais um.
Up to us to choose, as long as
interessante esse cálculo para primos, eu não conhecia, não.
We spend a lot of time doing matrix
coisa, né? Plonk 2 para mim é novidade.
So it's important to get the matrix right to make that particular matrix multiplication fast. There's a few tricks that we use in order to choose a good value. So our choice for the MDS matrix is firstly circulant. What that means is that every row is just the row above it, but shifted by one position. It means that there's fewer numbers for us to have to remember. We're spending a lot less time just loading constants from memory, which makes our code faster. Secondly, this matrix is composed of powers of 2. And multiplication by powers of 2 is way faster on a computer because you're just shifting the bits by some amount, as opposed to actually having to go through all the steps of multiplication. These powers are small, which makes the finalization at the end like way cheaper. And a lot of these elements are 1, which is like multiplication by 1 is free, like you just don't do anything. We make extensive use of vector operations. So most of the code that your computer runs is scalar. The computer kind of takes, let's say addition. You have 2 numbers and there's an addition instruction that takes 2 numbers and returns the sum as 1 number. But your computer also has what we call vector instructions. So these do more with 1 instruction as long as you're doing the same thing for multiple values. So you might have a vector of 4 numbers and there's an instruction to add that to another vector of 4 numbers, getting 4 sums as the result in 1 vector. Compilers are generally bad at generating these kinds of instructions. So if you really want to make use of this, that's a lot of work for the program. In Plonky 2, we make extensive use of vector instructions. This was a lot of work for us, but it's really worth it. So vector instructions give us a 2 times improvement on Poseidon. In addition to that, there's a bunch of ASMs scattered in the code base. So for example, the top one made finite field multiplication 10% faster. The bottom screenshots are from parts of our Poseidon implementations on ARM and on x86. Look, the result of all
na
this
verdade,
work
cada número, né? Que esse que parece ser um hash é um número
proofs, right? And
em hexa.
You've seen the impressive results from Brendan, but we're only getting faster. There's still no GPUs involved, for example. We didn't think that we wanted our users to need GPUs to run.
O Vitalik no paper dele ainda falou do uso de repente de ASICs. Ele volta no uso de ASICs só para resolver os cálculos de zero knowledge.
I'm looking forward to how fast we can get in the future.
Que é o que ele está falando. Hoje ele está gerando esses, fazendo esses cálculos em GPU. Agora imagina você ter um equipamento dedicado só a resolver esse tipo de cálculo, que é muito intensivo. É pesado, Tuco. Resolver zero knowledge é muito pesado. O que eles estão mostrando é que eles conseguiram otimizar todos os processos. Agora imagine se você tem o processo otimizado e aí você tem um hardware melhor para fazer só aquilo. Aí você tem uma performance formidável, né?
And we're happy to take questions.
É o que ele está falando, é o insight matemático mais o expertise de engenharia. Técnico.
Jacob and team, thank you so
né?
much.
Você otimiza na matemática, mas você também otimiza no equipamento que vai fazer.
We do kind of have a small caveat, which is we are running a little bit behind, so we'll have to cut the Q&A short. But there's one question that came from the audience, and that question was just overall, kind of how do you think about now new applications that sort of enable more things with just the Polygon ecosystem and also the Ethereum side, and just like with these new improvements, with these new performance metrics, how do you think about just the EVM world and what would now be possible here? Just giving that taste would be good.
Karthik, so probably, I should take this disclosure question, and, you just also wanted to, put a closing note also that, how this adds an immense amount of value to the overall Ethereum ecosystem and Polygon ecosystem. Is that this prover system, like, many who understands the ZK technology, they know that this is the most efficient and the fastest ZK prover system. And this will enable us to create a very high performant, highly decentralized ZK rollup or EVM compatible ZK rollup, which you can already imagine that if these, this will provide full security by Ethereum. And then, imagine you have a ZK rollup where it provides Ethereum, full security by Ethereum, and dApps can use that rollup at a much, low cost transactions by using Validium kind of systems, or, later on with ETH 2.0 data shards. It has a potential to provide massive scalability to, to the dApp ecosystem. And Polygon already has a huge dApp ecosystem, which is, we keep getting these demands that, we need to have more, Ethereum secured, and decentralized layer 2. And I think this takes Polygon community very close to that dream. And then what Brandon and team and Daniel and team are building is, would also provide, like, this is like a bit technical getting into it, but would, might also provide a virtual machine which has more opcodes to use to the developers, relevant to the question, that you can, like, the apps on this, layer 2 can actually run more opcodes, like that means more functionality, more features on this one, while still be fully provable, on Ethereum. So this is really, really massive for Polygon. And, with that closing note, I, want to congratulate the entire Polygon community that, this establishes Polygon at one of the topmost players in the ZK space. And let's build a highly adopted Ethereum layer 2 and bring the, mass adoption to Ethereum. Thanks a lot. Karthik, over to you.
Thanks, everybody. And congrats again to the Polygon Zero team. I think with that, we are ready to move on to our next talk. And for this one, I'd like to invite Paul and Chaitanya for to talk about Polygon Nightfall. So without further ado, let's welcome Paul and team.
Hello. Hi, everybody. Paul Brody here. So I'm the global blockchain leader at EY. And wow, so I was watching the last presentation. That is a very tough act to follow, but we are going to do our best. I'm only going to take like 2 minutes before I introduce my colleague Chaitanya, who is incredible. But I want to talk just a little bit about the history of Nightfall and how it became Polygon Nightfall. At EY, there's a couple of things that we spent a lot of time thinking about. One is, what is it that enterprises need, right? And there are a lot of brilliant people like Sandeep and others who have been thinking very heavily about scalability. Right, but one of the big challenges for enterprises is enterprises can't just use a mixer, right? Because enterprise tokens and assets are often unique. They're often attached to business contracts that represent complex business relationships. And so we have spent a great deal of our time over the last 5 years, really pretty much nonstop over the last 5 years from a research perspective, thinking about how to enable privacy at scale. Now, the first version of Nightfall I think, back when Ether was $100 a piece, we spent $3,000 worth of Ether just to build our prototype ZKP-based supply chain and move some tokens around. And that was an amazing piece of work, and it proved the case out for us. But we kept iterating, and where we ended up earlier this year was with Nightfall 3, which is a ZK optimistic rollup technology. And we built that out, and in cooperation with Polygon, we're really turning this into a layer 2 system where everyone can access private transfers and payments at scale with very efficient gas costs directly on the Ethereum mainnet. So that is kind of critical to our goal. And when we started talking to the different layer 2 providers, and there's a lot of them out there, and they're all populated by incredibly brilliant teams, but the relationship that we struck up with Polygon, with Sandeep and the team was incredible, because at heart, they understood a couple of really critical things that we shared with them. A huge commitment to public blockchains, an unshakable commitment to the Ethereum ecosystem, right? EY, we are without a doubt the biggest sort of large enterprise investor in the Ethereum ecosystem. We pour our energy into this ecosystem. And then thirdly, we're both very committed to ZKP technology, both for scalability and for privacy. And so that match, the relationship that we built over that, has been the foundation of the work that we've done. We are so excited about kind of where this is going. It's going to be, I believe we are all underinvested in privacy, that enterprises need it for sure. It's an absolute requirement. But I think far too many consumers and individuals are underselling their own value by not investing more in their own privacy. So I very much look forward to that. And I am incredibly delighted to hand over to my brilliant and talented colleague, Chaitanya Kanda, to actually explain what Polygon Nightfall does and give us a quick demo. Chaitanya, over to you.
Ela vai fazer demo?
Don't forget to unmute.
Thank you, Paul. Yes, I'm Chaitanya, and I work with EY's blockchain R&D team. Today, I'm going to show you a live demonstration of what Polygon Nightfall does. And hopefully, a very wise man once told that live demonstrations, especially of tech nature, are a career suicide. One that I repeat time and again, because I always end up with the short end of the straw. I hope today is not one of those days for me. Let me share my screen as I walk you through. Okay. Now, I hope you all can see a PowerPoint presentation. So I'll give you a bit of context about what Polygon Nightfall does before I give you the Nightfall demonstration itself. What is Polygon Nightfall? You all must be pretty much aware. The very first iteration of Nightfall was built as a privacy protocol, or it still is a privacy protocol. What it enables us to do is to do private transfers of ERC20s, 721s, or 1155s between two parties, such that the contents of that
já deixa fazer transferência de tokens de maneira confidencial na estrutura da Polygon. Polygon Nightfall. Vamos ver se a gente explora isso aí, hein?
So it's essentially a privacy protocol. Now, just to give you a high-level summary of how it works, because this is not the point of our talk here, you have three kinds of transactions. You have deposits, transfers, and withdrawals. With a deposit, what you do
Isso é sinistro, porque todo NFT, todo 721 tem um ID único.
Here, it's really a shield contract that sits on L1, and you take any tokens of ERC20 of a certain value, when you submit this proof called a deposit proof.
Token ERC20 é fácil. Eu quero ver com 721.
Equivalent commitment that holds the value you've just
tipo Tornado Cash.
A commitment is just one way to obfuscate the contents of a token. In terms of a deposit, that's really not private, because when you move tokens from layer 1 to layer 2 or back to layer 1, that's not where we get privacy. We get privacy when we're within layer 2 itself. So now moving on to the transfers, where we actually get private transfers itself, what we're going to do is, in order to spend a token, a user will first have to create something called a nullifier. A nullifier essentially spends the commitment they own, and there's no way to connect a nullifier to the commitment it belongs to. So all someone who's watching the blockchain can see is that something has been spent, but they can't see what has been spent and how much is within it. At the same time, when you're transferring something to some other person, what you're going to do is create another commitment of equivalent value that you've just spent. And obviously, because it's obfuscated inside a commitment, the contents of the commitment itself are not visible. So the value is hidden once again. And also the other piece of data that would be as part of this commitment is the public keys that the new recipient owns. So this new commitment
Basicamente, ele criptografa, cria uma espécie de recibo que a gente chama de commitment. Você passa esse recibo para o outro lado e aí o seu token fica sempre rodando dentro dessa plataforma, dentro desse smart contract, de um lado para o outro, e o commitment prova o quanto você tem. Isso não é exibido, isso fica fora da rede. Os commitments tipo, é um recibo de compromisso, né? Você locasse o token lá e o recibo você vai rodando ele por fora. Quem tem o recibo consegue sacar aquele valor. Mais ou menos esse é o conceito quando usa essas plataformas que têm essa commitment. Para optimistic rollups, legal se ela explicar.
So what's different between the version then and now is that it does optimistic rollups. At the very beginning, the cost of the transactions that we've done were quite high. They ranged about in the $100 nature back in the 2018. The reason why it's quite high is there's generally a lot of data that's been stored on the smart contract in terms of what's held in a Merkle tree, all the commitments and nullifiers, and you also you're just sending one transaction at a time. You're not really batching up. Now, both of these changes have already been modified where the smart contracts are optimized such that we really don't store any data that's not really required to be stored on a smart contract. And two, we also batch. But what optimistic rollup does, it takes it to a whole different level where you're really not doing a computation itself on chain anymore. You're really providing what the end state of a computation should be. And
então, essa parte é muito louca, né? Porque quando você fala optimistic rollups, é o que ela está explicando, a computação não é feita mais on-chain, então o custo cai, mas a computação é feita off-chain. E se você não precisa mais fazer como o Arbitrum, você não precisa mais fazer a computação on-chain, toda aquela treta do Turing Complete Computer feito pelo Ethereum seria mesmo necessário? Ou você precisaria só de uma camada para armazenar essas provas? Ser um banco de dados distribuído que armazene as provas e faça uma computação mínima, ao invés de uma computação complexa? É a pergunta que eu sempre me faço essa pergunta.
Layer 2 solutions exist in the form of both off-chain solutions and on-chain solutions. With on-chain solutions, there's usually two approaches one tends to take lately. You either use zero-knowledge proofs, snarks or starks of some kind, or you use optimistic rollups. Using both of these, you can either get the benefit of privacy with some very good scalability, or you can directly write it as just purely a scalability solution. Where Polygon Nightfall is it's an optimistic solution that uses scalability, but also provides privacy. You would know of other optimistic solutions such as Optimism and Arbitrum today, which are built to be scalability solutions from scratch. So moving on. Now, just to give you a comparison of private transactions, if you were to do an optimistic version of a private transaction as opposed to a ZK's version of a private transaction, what I mean is using Optimism for scalability versus using ZK for privacy. ZK for scalability. There's pros and cons to both of these. A very good pro for an optimistic solution is that the gas costs are way lesser. So the gas cost for Polygon Nightfall is about 9,000 gas per transaction. That comes down to about $2, $2.5 today. Based on various gas prices.
Então a solução da Polygon com o ZK
based off of 75.
é melhor do que o ZK de ZK da Aztec.
Now, on the other hand, with Aztec-like solutions, which is ZK solutions, they have finality much faster than optimistic solutions. They have finality pretty similar to what a layer 1 would have. Optimistic solutions tend to have a 1-week wait periods, predominantly because you would want to give enough time for challengers to challenge bad blocks if there exists any.
E isso é uma coisa que acontece nas soluções optimistic. Eles têm uma janela de uma semana para que qualquer um possa... Eles colocam como challenge, possa reclamar um bloco, né, antes de você poder resgatar os valores. Então, depositei numa Optimistic, seja Arbitrum, seja Optimism, o que for. Mesmo na ZK, você fez o depósito, na hora que você terminou todas as transações e você quer sacar, leva uma semana para poder sacar. Tá? Vamos comparar com a Lightning Network. A Lightning Network, você terminou as transações, você quer sacar, quer fechar o canal. Ele fecha o canal imediatamente, seta no Bitcoin, 10 minutos depois você tem lá o valor. Nesse caso aqui, você tem uma semana para conseguir resgatar o valor que você depositou inicialmente para abrir o canal, para setar o valor e entrar na rede.
With a Polygon Nightfall solution, it's relatively lighter in terms of the kind of zero knowledge proofs that you would do, as opposed to an entire ZK solution.
É bom porque você está trazendo uma camada de criptografia aí que não tem no Bitcoin, né? Ainda. Mas eu acho ruim essa solução de ter que esperar uma semana. Todos os Optimistic Rollups levam uma semana aí para você conseguir resgatar.
Transactors are users who generally create transactions such as deposit, transfers, and withdrawals.
Essa parte é importante.
And then they submit them either directly.
É como se tivesse um blockchain rolando dentro do blockchain, entendeu? Então a Optimistic ela rola blocos usando smart contracts que vão ser setados de tempos em tempos na rede principal.
Those will have to be submitted directly and always to the blockchain. Block proposers then take all of these transactions that they receive from various users and they put them into different L2 blocks. And they submit these L2 blocks into the layer 1, which is Ethereum in this case. Each layer 1 block on Ethereum can hold more than one layer 2 block, depending upon how big these layer 2 blocks are. And that would exist so the state of L2 blocks, the final state they hold would exist in layer 1 inside layer 1 blocks. Now you have a third player called challengers who are continuously monitoring the system. What they do is that they will take these blocks that are put up, these L2 blocks that are put inside the mainnet. They will check the validity of both the blocks as well as the transactions.
Você tem uma camada muito clara, onde os block proposers são esses smart contracts da plataforma. Ou é Polygon, ou é Arbitrum, ou é Optimism, o que for. Então ela é bastante centralizada, porque quem propõe esses blocos internamente são os protocolos, tá? O que você descentraliza são os challengers. É quem vai verificar esses blocos e vai abrir uma disputa caso o bloco não esteja correto. Então, os blocos, por que ela é rápida? Porque ela é otimista, como o nome diz, optimism, ou optimistic. Eles são otimistas. Os block proposers, que são esses smart contracts, eles estão crentes, acreditando que tudo que foi proposto ali é verdade. Então, ele só vai setando transação. É tipo o protocolo UDP, manja? Que o UDP você só envia, você não tem que fazer aquela verificação e fechar as duas pontas como no TCP, você envia. Recebeu. Você acredita que enviou, foi. E aí você tem uma camada de challengers que vão ficar verificando esses blocos que foram gerados e transações que foram acontecendo. Então você divide esse trabalho em duas etapas. Hoje tudo é verificado a todo momento, né? Então os caras estão falando, para que fazer, verificar? Se o smart contract está fazendo a matemática dele está correta, verificou a transação está correta, vamos acreditar que o bloco está correto? Empurra. Manda para frente. E aí, durante uma semana, você tem uma semana para esse bloco ser contestado. É challenge, né? Contestado aí no caso.
There might probably also be a bounty program run simultaneously after the mainnet deployment. And finally, there will be, after the mainnet deployment has been successfully run for quite some time, of course, the restriction will just be lifted and for there to be no restriction in terms of the transfer at all. That's everything in terms of context. Now I will move on to the fun part for you, but the scary part to do a tech demo of me. This here, what you see is a Polygon.
Eu quero ver o RC721. Esse que eu quero ver. Quero saber se ele vai ficar locado lá dentro e você vai jogar ele de um lado para o outro só rodando os commitments, o recibo do dono fora da rede. Porque você olha, ele está lá, mas você nunca sabe quem é o dono. Eu acho que é isso que eles vão fazer.
Wallet is run by any user who wants to use this layer 2 solution to do transfers of private nature. All of the keys, both that pertain to the transaction, the keys that will be used to send transactions to the Ethereum blockchain, or the keys that correspond to the layer 2 itself, which is the secret keys that will give you ownership of commitments. All of those are stored within user's browser. So none of this will be inside a server anywhere. So this will have proper privacy for a user, and everything in terms of privacy sits at the user's end in their browser. Now, another thing is notice that here we have ERC20s and
vamos comparar com o programa aqui, vamos comparar com o EDOS TV. Qualidade está animal, né? Vamos falar que aqui tem cuidado com o que está indo, né?
And yes, that's pretty much everything before I go on to give you a demo. So firstly, I will start off by doing a deposit of ERC20 to myself, which means when I create this transaction and I sign this transaction, what's happening is that the very first transaction was to approve the Shield contract to take some ERC20 balance from my ERC20 contract.
O que ela chama de Shield Contract é o contrato que vai mascarar, que vai... Você vai mandar esse token, provavelmente ele vai ficar dentro de um contrato. E o dono vai passar para lá e para cá, só viu o contrato. E quem tiver o commitment final pode sacar do contrato.
But it says pending deposit, so that's interesting, right? Why is it not part of L2 already? We've got to remember that it's a roll-up solution where lots of transactions are required to be put into a block. At the moment, all I have is just one transaction. Before I go any further, I just want you to show what other players exist here.
Quase nível BBC, né? Tem vinheta, tem clipe, tem tudo, né? Vamos ampliando aqui o bloco verso do EDOS TV.
The other users are sitting here. So you have a block proposer, and you can see that a block proposer was started.
Não necessariamente. Quer dizer, com Zero Knowledge reduz, sem dúvida. Sem dúvida reduz. Porque você está fazendo um bloco com provas da transação. Não é um bloco com a transação, mas são provas de existência da transação. E a prova é muito menor do que a transação em si. Na verdade, um bloco confirma 1 milhão de transações, por exemplo. Poderia. Embora seja um bloco grande de cada vez, ele tem um potencial de englobar 10 milhões de transações em um único bloco do mesmo tamanho. Por isso que diz ser que aumenta a velocidade.
I'm picking a token ID 1. I'm submitting this from... I'm approving this first.
Tá fazendo a mesma coisa. Primeiro ela está aprovando no smart contract.
So what happens now is that this ERC721 token has to move from L1 to
Então, então olha o que aconteceu. É exatamente isso que eu falei. Saiu do Ethereum no Layer 1 e agora está no Layer 2, está no Smart Contract. O Smart Contract é dono desse token. Tá? É o que aconteceu agora, nessa primeira transação dela. Então, primeiro teve a aprovação. Então, você tira o valor da rede principal e loca no Smart Contract do rollup, né, desse Layer 2. A partir daí, ele está dentro de uma nova rede. Ele está dentro de um metaverso. Então, esse metaverso agora, você vai poder transferir para as pessoas utilizando Zero Knowledge Proofs e gastando muito menos. Mas a primeira transação você teve que fazer.
For the user myself, so both of us are doing our jobs quite well, and we're both pretty happy. Now, what I want to do is I want to do a transfer. I want to do a transfer of an ERC-721, let's say, to somebody else. The default address is to myself, but that's not fun, is it? So I'm going to do a transfer to somebody else. And let's pick a token. There's just one token in layer 2 for the moment, in ERC-721. I pick that and we'll submit this transaction.
Então, primeiro ela fez o depósito. Agora ela vai fazer a transferência para ela mesma. Mas
pretty soon you will see that this L2 transaction that I have goes into pending outflow. Once again, it's pending because it's not been proposed as an L2 block onto L1 yet. We need a second transaction to create some blocks. So I'm just going to create another transaction. In this case, let's say a deposit.
Como é em BET, ela vai precisar criar uma transação genérica para elas serem acumuladas e a rede aceitar, porque só uma transação, a rede está esperando mais transações para poder setar, né? Então é BET o processo.
Now, you will see that.
Por isso que ela está lá no pending outflow. Saiu.
Now you will see two things have happened. A block must have been created. Yes, indeed it was.
Foi criado bloco.
Created. So I now have a balance of 20 because I had 10 originally and I just added 10 more. And I'm less by one ERC-721 token. So just to quickly give you an overview, there is a second account here, obviously, that I used to send it to. And that second account has a balance of ERC-721.1.
Ela trocou a conta lá em cima, tá?
For the moment, I'm just running the second account in the browser myself. The keys, the layer 2 keys that we're using are very different here, but layer 1, they're both the same people because I'm the same person. So my layer 1 balance, according to that Ethereum address, is still the same, but under layer 2, I have two different accounts.
Ela tá mostrando que a segunda pessoa, agora ela é dona desse token. Ela só variou as contas. Ela estava com a conta A, que é a conta que tinha o token e mandou o token. Agora está mostrando para a conta B, que é a conta recebedora, tá? Quem recebeu o token. E mostrando que a conta 2 tem o token. Então, no Layer 2, diz que o token é dela. Era o João e a Maria. O João mandou para a Maria, ela trocou para a conta da Maria e mostrou que a conta da Maria tem o token.
I will click on withdraw and I'll submit 10. But you've got to remember, if I just click submit
agora é sacar, né, que é a história. Você vai pedir... Beleza, tá rolando toda essa zona lá dentro. É que nem você pôs você abriu o canal na Lightning, fez todas as transações que você queria na Lightning Network e agora você vai fechar o canal e sacar o valor. É isso que ela está fazendo. Ela está sacando o valor. O conceito, a analogia é a mesma. Qual a diferença que agora eles estão fazendo de uma maneira rápida com baixíssimo custo. Eu queria ver os custos de FIIs aí. Ela está mostrando só a funcionalidade. A funcionalidade para a gente é fácil, né? A usabilidade, ok. É fácil entender como funciona a mecânica. Mas eu queria ver em matéria de FIIs. 0,25? Eu vi isso passar ali na tela dela de FII. Total mais amount 0,25. É isso? Mano do céu, velho.
But there's also an update to my L1 balance. I moved 10 out of my pending outflow.
Você nunca mais vai tirar seu token de lá com o Ethereum se ele não resolveu a questão dos FIIs dele. Você tá maluco, mano.
The $10 instead of waiting for a
Você
finality
tá
of 1 week.
maluco. Como que um ser humano, nós, a plebe, vamos parar e usar uma parada dessa, mano? Você tá louco, cara. Nossa, mano.
The mechanism behind this is this. When I create an instant withdrawal, what I'm doing is submitting a request.
Você tem Ether preso na mainnet, né? Eu tenho W-Ether preso na mainnet. Eu tenho o maldito do Ether tokenizado em RC20, meu amigo. Eu tô ferrado para tirar isso de lá. Nunca mais vai sair. Já mostrei aqui na live. Nossa, mano. Vai ficar lá até...
The wait time I would have gone through of a week period onto themselves. So liquidity providers...
vou tirar $100 e pagar 800 de FII.
Continuously monitoring the network. So they would know if they give me the money straight away today, is that safe or not?
Mano, 0.25 você tá falando de milão. Tá mais de 4K o Ether. Você tá falando de milão. No mínimo. Milão de doll. Que eu comprei com o lance da DAO, exatamente, Fábio. Foi daquela história da DAO. Eu me lasquei.
And they will receive the money that I would have received a week later. So that's what's happening with the liquidity provider. So just one final interesting case I'd like to show you. I'm going to do just 2 deposits for this of ERC20.
0.25 vai sacar. Você tá de brinks, mano. Se você dizer, vou sacar 10 milhões. Vou pagar $1.000 para sacar 10 milhões? Eu tô um pouco me lixando para esse 0.25, né? Agora, você tá maluco, é muito caro. Quer dizer, entrar e sair da rede, né? Entrar e sair.
I had a balance of 30 earlier, but now I only have 10 and 20 were moved back to pending deposit. So what just happened with something naughty? Let's look at it. You see there's a block proposer here, and clearly, so far block proposers has submitted 3 good blocks, but the last block that he just created with my 2 deposit, he purposefully created a bad block of type incorrect root, and he submitted onto the blockchain. So what happened was, as soon as this block was submitted, because that was part of that was a block that's part of Ethereum now in layer 1, my balance got updated saying, well, your balance is now 30, but clearly somebody was monitoring the network, which was a challenger. A challenger was monitoring my network.
Eu não tinha nenhum W-Ether, Jeff, eu não tinha. Eu fui fazer uma demo pro bloco e loquei, tive que pegar uns W-Ether, fui lá e loquei. Me lasquei.
So as soon as they verified, there was a warning. They said, block checker, block invalid with so-and-so issue. As soon as that error was picked up, it then tries to create a commitment for the challenge, which is challenging incorrect root. And eventually, it would have submitted the challenge to layer 1. Our challenge commitment has been mined and sending reveal, which is, yes, reveal is to reveal the challenge itself. And the challenge would have been provided to layer 1. Layer 1 will then do the computational steps of the challenge itself. And on successful challenge,
espero que seja que ela tenha colocado valor arbitrário, vai.
The first bad block
pode ser também, pode ser. Né?
When that happens, a rollback.
Não sabemos se ela está fazendo, porque como é testnet, ela criou lá e ela está colocando quanto ela quiser. Porque, né? Mas se for isso o fim mínimo para operar, ficou cara a brincadeira.
Waiting to be deposited and I don't have that balance yet. Now, what happened was I only have one proposer, as you can see. And as soon as this bad block was submitted, this proposer was basically slashed. So they're no more the proposer. Now, on a good day, if I were to have another block proposer right now, these transactions would have ended up back in the mempool for the second block proposer to have picked up, and they would have submitted for me. So these transactions would have eventually made it back to L2.
Ela está explicando aí na testnet,
That's just the way the entire network works and the different pairs.
Ela está explicando, né, como que funciona a mempool no caso de uma proposta de bloco inválido, como que ela fica lá e volta para a mempool, tal. Tá só ilustrando isso agora.
That's pretty much everything, really, in terms of demonstration. I'm happy to take any questions now.
Eu espero que aquele 0.25 tenha sido um valor arbitrário que ela usou só para fins de demonstração.
Is that you always execute them and then look like a rock star. So thank you so much. I'm sure Karthik's going to tell us that because of the time constraints, there are no questions, but really, truly brilliant. I'm so proud of the work that you have done, the R&D team that has done, and the work that we are doing in cooperation with Polygon to make this real.
Paulo and Titania,
Enquanto eles vão fazer esse mini intervalo, eu vou correr no toalete, eu já volto segundo aí.
Before I ask that question, I want to just say I've just been looking at hundreds of comments and everybody's just been extremely happy with how easy you made that to understand and follow, and of course the demo works. So I just want to make sure that I point that out. It was a super conveniently well-made, easy to follow presentation that covered really technical topics. So thanks for that. The question is a simple clarification that came in from one of the listeners, and the question is: would challengers be able to reverse transactions made a mistake, such as kind of giving an invalid wallet address or any other keys, and kind of just how does if it's possible to reverse a transaction upon finality, I guess.
So yes, there's a 1 week finality period. You really have to do any sort of challenge within that period. So there's various ways a transaction or a block could be wrong. Either the transaction that was submitted to begin with was invalid, but the block browser still went ahead and submitted it as part of a block, or the block itself that was created with these various transactions was malformed, and that was submitted onto the network. What then happens is that block now is part of layer 1. Let's say other blocks were continuously proposed on top of these blocks as well. At this point, a challenger who's monitoring the system, they would pick up this very first block proposed, that was wrong block. They will then submit a challenge that challenges that very block. And when that happens, all of the blocks along with this block and the ones that come after will be rolled back. So that entire state is basically rolled back. And when that rollback happens, that rollback is not just happening in layer 1 of the blockchain. Everybody who's keeping track of their own state in terms of commitments or transfers or transactions, they will also have to update their own state. So block proposers, challengers, and users, they will all update their own state according to the rollback that happened. I'm not sure if that answered your question, Karthik.
I hope so too. We'll see if there's a follow-up question that comes in, and if there's still any confusion or follow-up questions, I'll just ask them directly over email and connect you both. So thank you so much with that amazing presentation, and we are ready for our next talk.
Thank you.
So next up, I want to invite Bobin to talk about Polygon Maiden. So Bobin, whenever you're ready, feel free to get started. Welcome.
Thank you, Karthik. And hello, everyone. Very excited to be presenting amongst such brilliant people and talk about Polygon Maiden. Let me just share my screen. All right, I hope
Mas
everybody
não,
can see the
Jeff,
presentation.
essa aí é o seguinte, é 0.25.
So, before I explain what Polygon
Se
Maiden is,
você, primeiro você precisa alocar o recurso no smart contract para depois fazer as transações lá dentro a baixo valor, saca? Então, para entrar no smart contract, para tirar do smart contract para sua conta, é 0.25. Depois, tanto faz, porque quem vai gerar esses blocos e vai setar é tudo a rede lá, tá? É tudo a rede. As transações lá dentro, de um para outro, ficam super baratas, com FII baixinho e tal. Super fácil. Mas para entrar e sair que o bicho pega.
So the next thing I try to do is I start to think about Stark-based virtual machines. And I actually made this ETH research post early in February 2020, describing kind of my thoughts on it. And at the time, I actually didn't think it was going to be a very powerful machine. I didn't think it was going to be Turing complete. But as I started working on it, I realized that there are a lot of things that we can unlock, and there is actually a way to build a practical Stark-based virtual machine. And a few months later, I built the first version of the Staff VM and improved it over the following months.
Ele vai falar dos Starks, né?
VM is actually one of the foundations
Legal
for Polygon Maiden. The other foundation of Polygon Maiden is Winterfell, which, after I worked on the Staff VM, I joined Novi, and as part of being there, built this Winterfell Stark prover. It's in a way very similar to GenStark, but it is much more performant, modular, and up-to-date implementation of Stark protocol. And now Polygon Maiden VM is kind of a combination of Staff VM and Winterfell, and in a way it is a culmination of what I've been working on for the last 2 years, so to say. So I'm very excited to kind of talk about it. So what exactly is Polygon Maiden? Polygon Maiden is general purpose, Stark-based ZK rollup. And I know a lot of people here are already familiar with all of these terms, but for those who are not, let's go through these terms one by one and start with ZK rollup. So what is a ZK rollup? In a ZK rollup, we have users, operators, and then we have an on-chain contract, which is on Ethereum main chain. And the idea is that users send transactions to operators, and there are many users, and operators aggregate those transactions into batches, and then they submit kind of the state change or whatever has changed in the internal state of the ledger that the operators are managing, together with the ZK proof that they verified all of those transactions to the on-chain contract, which verifies that. So why do we care about this type of setup? And one of the answers is that it gives us lower fees, because we can compress a lot of things using ZK proofs, and there are other reasons why. For example, we don't have to include every single transaction if some transactions happen between the times that we verify ZK proofs. And those
Vitor Chaves, obrigado pelo sub, obrigado pelo Prime. Tamo junto. Valeu pela força.
So we can get up to actually over 100x.
Mais membro do bloco, mais minerador aí do nosso blocoverso. Obrigado, Vitor.
That is important is we can get this without sacrificing security. So in the ideal scenario, the ZK rollup is just as secure as Ethereum itself because it inherits security from Ethereum. There is no way for operators to submit invalid transactions or submit a state transition in the ZK proof for something that is not really valid. So if they didn't have a transaction to verify, they couldn't make it up. The other exciting part is that,
é isso que ele está falando, fazer uma pausa. Você faz as transações nesses operadores, os operadores são o Nightfall, Arbitrum, o que for, ele zera o ZK Proof e manda para o contrato on-chain, né? Aí que eles estão falando, você gera 100 vezes mais rápido do que o Ethereum, 100 vezes mais barato do que o fim do Ethereum. E chegando a 20k transações por segundo, depois que tiver sharding. Agora já está na casa de centenas.
This kind of setup allows us to have much more flexibility and experiment with different consensus models, execution models, and structures of the ledger, and achieve this high.
E ainda tem uma história aí ainda, tá? Jeff, para você ter ideia. Vamos supor que você depositou o seu NFT na Arbitrum. E aí você vai transferir esse NFT para alguém que está na Optimism. Você precisa ter uma ponte que vai tirar ele de uma rede para depositar na outra. E você ainda vai ter uma semana de gap. A questão toda é, você vai pagar o fee de retirada de uma e o fee de depósito na outra. Óbvio que se você fizer numa transação só, não vai pagar tudo isso. Mas tem um fee gigante. Como que vai funcionar a interoperabilidade? Imagina, aí você tem todos os seus NFTs em uma rede que é você tem seus NFTs, seus tokens num smart contract, mas o cara usa outro, o cara não tá na Arbitrum, o cara não quer pagar a FII para entrar na Arbitrum, ele já tá no Optimism, ou tá na Nightfall, né? E aí você tem que pagar um fee de saída e um fee de entrada do token na outra rede. Como que fica? Hoje é caro, tem soluções que eles estão pensando aí para manter locado em um, enquanto você negocia na outra para tentar baixar o fee. É difícil, né? É caro a brincadeira.
Without having to do the computation themselves. And it's very important for in our context that the proofs are small and fast to verify. So overall, in terms of proofs of computational integrity, there are two large families, Starks and Snarks. Stark stands for Scalable Transparent Arguments of Knowledge, and they were developed by brilliant people at Starkware. And there are a lot of different Starks developed by many different teams, and they stand for succinct, non-interactive arguments of knowledge. But rather than saying like there are two different families, there's actually a lot of
Exatamente, Jeff.
And non-interactive Stark is actually also a Snark. And the scalable transparent Snark is also a Stark.
E às vezes a aplicação vai estar em mais de um. Ela vai fazer uma lógica externa, mas ela vai estar presente em mais de um para poder, inclusive, cuidar dessas transações, né? Usar bridges e tal de um contrato para o outro.
A roll-up type system, and I'm going to go through them in the next slide. So Stark advantages, as I mentioned. Comes from the name. Starks are transparent and scalable.
Isso é muito legal no Stark, você não precisa do Trusted Setup. Vai que vai, junto com Zero Knowledge Proof, só vai. O Hell, quando eu desenvolvi, não existia esse conceito de Starks. Eu usei Zero Knowledge Proofs, usei ZK Snarks. Então precisa de um setup confiável e depois rola tudo lá. Mas nesse formato que eles definiram, pode ser muito melhor. Pode não, tenho certeza que é muito melhor. Sou muito mais fã de Starks do que o Snarks hoje em dia, né?
They're very flexible, and here I'm getting a little bit too technical, but we had the talk from Polygon Zero where they talked about selection of a field, and the same applies to Starks as well. You can choose a specific field which is very performant and allows you to generate proofs faster. You can also dynamically kind of trade-off between prover time and proof size, so you can increase prover time while reducing proof size, and play with different security levels without having to modify anything kind of in the proving system. You can do it. You don't need to choose a different elliptic curve. You don't need to redo your circuits. You can kind of dynamically trade off these properties and tailor it to a specific use case. And then in terms of performance, this is, I think, one of the big advantages of Starks as well. First, the verification is very light. In terms of like real world performance, most of the proofs that for any practical computation are just single-digit milliseconds to verify. And the description of the computation is succinct as well, because there is no pre-processing that needs to happen. And then on the prover side, the proof generation is also very fast. So a few benchmarks on the current implementation of MightyVM is that right now on a single CPU core, you can verify, you can execute about 10K instructions per second, which is 10 hertz. If you think back to,
cara, essa verificação de 2 a 5 milissegundos para verificar a prova é muito legal.
Like multiple seconds for a single instruction to be executed on a tiny RMVM. This is already many orders of magnitude improvement, but it gets better because we can parallelize very easily, and even with the current implementation, we can get up to
olha lá o que eles estão falando, esse nó com esse VM dá para escalar, você paraleliza. Paralisa as threads, paralisa
GPUs and FPGAs in the future where there is hardware acceleration. This is going to be in the
no futuro aí podendo ter uns ASICs, vão poder ter GPU e ASIC, começa com FPGA. Cara, de FPGA você vai para ASIC, né? De FPGA você vai para ASIC.
Usually proofs are in dozens of kilobytes, so just a few benchmarks for MightyVM in its current form. If you execute 1,000 cycles, the proof size is about 35 kilobytes, and for 1 million cycles, it's around 80 kilobytes. And if we need to go more, it grows, but it grows logarithmically, so it's not gonna get too big. It's probably not gonna exceed 150 or 200 kilobytes at most for pretty much any practical computation.
Eita, Pirinho, você viu aí, ó o Fábio. Ó o Fábio, dropou aí uns tickets para você aí, ó, Pirinho. Valeu, Fábio, obrigado, cara. Valeu a força.
On Ethereum, but once EIP 4488 comes through, we should see that gas costs drop to hopefully under 1 million, but this will need to be verified. But,
nossa, 80k de informação para 1 milhão de ciclos nessa VM, cara, é muito bom.
The cost of verifying Stark proof will get reduced significantly as well. The other thing is recursion, and it is possible to do recursive Starks. They haven't been demonstrated yet, but especially in the context VM, this becomes like having.
Usa bastante gas, cara. Tá falando de 3 a 5 milhão gas. Um bloco no Ethereum tem acho que aumentaram um pouco, mas estava na casa de 6,4 milhões de gas. Então, só uma verificação ocuparia praticamente um bloco inteiro do Ethereum. Fica caro, né? Como que você paga por um bloco sozinho? Como que você paga por mais de meio bloco sozinho? É caro. Apesar de você poder pegar o feed de 1 milhão de transações, né? Assim, o custo-benefício é alto, mas se você tiver só uma transação para setar no bloco, você se lascou, né? Uma transação a 1 milhão vai ter o mesmo tamanho.
And building a general purpose ZK rollup requires to have at least you need to have a zero knowledge virtual machine. So, in the context of
cara, isso é muito legal, cara. Uma Zero Knowledge Virtual Machine é muito legal. Pena que o nome vai me lembrar o Biden para sempre, né? É Biden. É sacanagem, né? Agora buguei todo mundo. Polygon Biden.
And you'll get a single proof that says all the programs have been executed correctly. One other distinction is that you can provide this witness data. For example, in the blockchain context, this could be signatures that once the VM has verified them, you don't really need to include them into your proof that goes onto Ethereum. So you can basically discard this witness data, or it gets discarded, and that allows you to significantly compress things that need to go onto the main chain. In the context of Polygon Maiden, we have Maiden VM, which, as I mentioned, is based off of the staff VM. And let me give you a few highlights.
Até a careca do Biden ali no meio, ó, com um fio de cabelo ali, ó.
So one of the main focuses that we want to have is to have the VM be developer friendly. And by that I mean we want it to be as close as a typical virtual machine that you might have encountered outside of zero knowledge or a cryptographic context, so that you don't really need to learn anything about cryptography. So, for example, it's going to be a simple stack-based machine. This is what Polygon Maiden is right now. It is going to support natively 32-bit integer arithmetic, so no need to think about field elements or understand finite fields or anything of that sort. You can just work with 32-bit integers. It will have read-write memory, so very easy to kind of like learn how to use it. It will have native exception handling, which is very important in the context of smart contracts, where one contract can call another contract, and the other contract can fail. So we want to make sure that even if there's a failure somewhere, we can still prove that the original smart contract that called the failed contract executed correctly. We are planning to build a very extensive standard library, which will support all kinds of goodies that developers in the for smart contracts and DeFi might be interested in. The other important thing that I want to mention is that we want to make Maiden VM a multi-language. Solidity will be the first-class citizen in this VM, but we also want to make sure we can support other languages, such as, for example, Move, or other languages that people would want to compile into Maiden VM assembly. One of the other design goals, and it is kind of related to multi-language support, is that we want to make the VM safe, and actually safer than EVM itself. So we will not allow dynamic call targets, you still can compile Solidity into this, and it still will work fine. But underneath, the VM will be safer than the EVM itself, which will also make making bugs potentially much more difficult, or putting bugs into your smart contracts. And then taking some hints from like Rust programming language, all operations in the VM are safe by default. And there is also privacy focus, kind of like we want to build in some privacy features into the VM, but this is not the focus right now. This is, but we do want to make sure that the groundwork is there, where we want to support both data and functional privacy in the future, so that the VM can execute kind of privacy preserving smart contracts. And just to kind of like show this diagram of how we think about multi-language, so Solidity can be compiled into YUL intermediate representation right now, and then we'll have this YUL to MIDEN transpiler, which will transpile YUL into MIDEN assembly language, and then the MIDEN assembly language is the native language of MIDEN VM. And then other languages will be able to compile into MIDEN assembly as well. So I talked a lot about where we want to go. Now let me give you a little bit of a roadmap.
Que bom, cara. Eu também estaria pá se eu tivesse aí numa fila do Santander, cara.
Last month we released the version 0.1 of MIDEN VM. It already has kind of stack manipulation, arithmetic operations, and basic control flow implemented.
Olha o timeline para 2023. Cara, a gente tá falando de 2 anos, 1 ano e pouco, vai. Vai atrasar? A gente vai atrasar? A EVM ainda não suporta a compilação do Solidity, vai aceitar só lá na frente. Cara, a gente tá num momento ultra early. Isso aqui funcionando na Polygon. Então, ó, vamos pensar em ZK Rollups funcionando no Ethereum, num cenário em que não tem atraso, meio de 2023 para frente. Porque antes disso, a Polygon é o laboratório de ZK Rollups, tá? Para 2023. Vale muito a pena ficar de olho, porque isso aqui não tenho dúvida que vai dar certo. Tem 1 bilhão no fundo para fazer esse negócio dar certo. 1 bilhão. Vai funcionar, vai atrasar. Mas, cara, olha o futuro. A gente está num momento ultra early desse negócio. Vai ser animal. O que vai surgir de projeto, que vai ter coisas no entorno desse ecossistema. Vale muito a pena acompanhar o que vai acontecer com a Polygon. Agora, 8h19, já vai entrar o último painel já. Olha o endereço, repo.
Not to have a single operator, but to have kind of a network that is fully in
github.com/matic-network/MIDEN.
And here is the link.
Vamos forcar e fazer o Biden, o Zero Knowledge Biden Proofs para o bloco.
With that, I'll open up to questions if there are any.
Thank you so much, Bob. And this was an incredible overview on all these improvements that you've kind of made with the help of your team. We don't have any questions specifically to what you've talked about. It's just been comments from like, this is incredible. And some of these things are just amazing that people are enjoying. If something comes up, I will happily share them on the chat here to you in the Zoom.
Mas no Biden, Zero Knowledge Biden, você vai poder emitir Ethers ou tokens e imprimir à vontade, sem ninguém ficar sabendo.
Well, thank you so much. And with that, we are ready for our
Você faz um depósito de token RC20, ele multiplica para você, sem ninguém ficar sabendo. Porque, né?
Jordy's going to be talking about Polygon Hermes and especially introduction to the polynomial identity language. So without further ado, let's welcome Jordy.
Que a inflação gera oportunidades.
Thank you very much. Let me share my presentation right now.
né? Quanto mais gas, melhor para ele, maior a inflação, maior o gasto.
Starting, I just want to welcome to the Polygon Zero people.
E tem um gerador de desculpas.
Luxury to have them on board and very excited.
Isso aqui é legal, isso aqui é legal. Vamos ver.
We're already, as
para ZK EVM, ó.
Brandon already said, we have been already working with them in the last weeks and has been very productive. And I also want to thank you to the.
Cara, quando a gente está falando em instruções e computação e criptografia, não se fala em outra coisa hoje que não seja em linguagens que não sejam polinomiais. Hoje em dia, né? Hoje, a do momento. É o hype da área técnica.
So with that said, I'm going to present today the pill. Just to understand where the pill fits in the project.
Vou jogar Valorant lembrando aí do piu-piu.
Okay, so the idea of the most critical thing for rollup is generating this proof. Generating this proof is quite hard, but the idea of this proof is we have an auto state, we have many transactions. In the case of Hermes, we have normal Ethereum transactions. We want to be EVM compatible by code, but by code. We don't want to compile or just using the compiler. We just want to implement the actual bytecode. So we have normal Ethereum transactions, and we want to create a new state root. Okay, so building this circuit is deterministic program. This circuit is the challenge. So to build this circuit, what we do is we have mainly the project that we are following right now is we are building a Stark, and then in order to reduce the gas cost to 300K or even lower, is just to verify this Stark with a Plonk or Growth 16 proof. Okay, so this is the main approach, and the fact of using Starks, this is a little bit a game changer between traditional R1CS systems like Plonk or Glow16 and more polynomial based. This is in comparing with electronics. This is just working with normal ANDs and ORs, normal gates, and you just put them, a lot of them. Or when you
então, isso aí que ele está explicando agora é que você tem o Solidity. O Solidity ele vai ser compilado e interpretado, vai ser compilado, né, para uma outra linguagem que é esse PIL, que é o que vai cair dentro da EVM. Então a EVM vai identificar. Pode acontecer, se não, obviamente vão trabalhar para que isso não aconteça, mas se tiver erro de compilação ou de transpilação, um monte de vulnerabilidades começarão a ser exploradas aqui. Dentro da EVM. Porque não é só o Solidity compilando para um assembler puro. Saca? Não é um assembler purão. Ele vem para outra coisa aqui que vai poder, justamente para poder trabalhar com os Zero Knowledge Proofs.
With this relationship, with this set of relationship, with this compiler, this will be used for generating the Starks, for generating the prover of the Stark, and then the verifier of the Stark. Okay, so to start, I think the best way to understand how
podia ser mais devagar, cara. Tava entendendo o gráfico.
Do an example of how this works. Okay, let's start with what would be the hello world of this language. In this case, we are defining a very simple state machine that actually computes 32-bit numbers through from two numbers of 16-bit numbers. So it's a state machine that has two steps. Okay, so we just even steps and odd steps. In the even step, we just get a number and put it in a register. And in the second step, we just shift the register and add the second number. And then we start over again. So we can generate as many
32-bit numbers as we want. So we have one register, in this case.
Bom, tem o primeiro número, você tem um shift que pega a segunda parte do número e junta com a primeira. É isso que está fazendo aquele mapa lá.
Put each value, and every 2 steps we are generating one new 32-bit numbers. So
e aí tem uma saída com um novo número. Tá, tudo bem. Duas entradas de 16 bits, faz um shift e passa uma saída de 32. Tudo bem.
The first number is 1, the second 0, 1, 0, 1, 0, 1, 0. It's the instruction what it's doing. Okay, we have the frame, the input of the system, the number that we freely can set to any number that we want, and we have the register itself, the register out. Okay, so in this, and then we start defining the constraints to these polynomials. The first constraint is that we are forcing that freeing is it's a 16 bits numbers. Okay, in this case we are doing, it's included in another constant polynomial that we have defined it here on top, that includes all the numbers between 0 and FFFFF. So all the 16-bit numbers. Okay, so with this we guarantee that the freeing can be any number, but just between 0 and 0xFFFF. Okay, and then we define the constraint for this state machine. Actually, we are saying that the next step must be if set is 1, so it's the first step, then this is going to be 1. The second part, this is going to be 0. So the first, if it's 1, we are just putting the input to the register. Okay. If a set is 0, so it's the second step, then this is going to be 0, but this second one is going to be 1. And then what we are doing is we are shifting the out.
Está mostrando o código para fazer o que estava na tabela anterior. Basicamente.
That's going to be maximum 32 bits number. Okay? So, and we define it this way. Okay. Let's move to a more complex state machine. In this case, we are going to define state machines that generates groups of 5 numbers of 32 bytes numbers that fulfills this relationship. A times B plus C must be D to the 32 plus E. Okay, so we are dividing this most significant bit and less significant bit. We are doing the arithmetic operation. In this case, it's a multiplication and a division. Okay, so how we do that? Okay, we have a state machine with 5 registers, A, B, C, D, and E, and the idea is that in the 5 first steps, we are just latching. We are setting. We are putting the input. We are setting these registers.
Está colocando um em cada registrador, tá?
And when setting E. And once
e o LED, que é o número que eles vão utilizar.
Then we force the condition. Okay. When we have to force the condition, well, we have this next polynomial. We call it latch. That's actually when you want to force that this condition fulfills. So we have a state machine where you just load 5 numbers, and then you are forcing that these 5 numbers are fulfills this condition. So how would we write that? Well, we will write this. We have this constant polynomial, set A, set B, set C, and set D, and set D. We have also the large polynomial, okay? And we have also the freeing, it's the input, and then we have the 5 registers, okay? And here we start adding the constraints. The first constraint is we say freeing must be...
Tá, lembra do gráfico anterior? Que assim que você define o freeing, na próxima linha ele vai somar e concatenar, tá? Aí ele está explicando o código. É isso que ele está fazendo. Está explicando o código que gera aquela tabela lá daquele jeito, com 5 registradores. O que ele está falando é que o state machine daquele processador, daquela VM, trabalhando com 5 registradores, como que ela vai funcionar para gerar os números de 32 bits.
A prime, B prime, C prime, and D prime, and this is if set A is 1, then we just set the free into A, and if it's 0, we just keep the last value. Okay, so this is the conditions for the next A, B, C, and D. Okay, and finally, when latch is 1, we must fulfill that mulsum is 0. And mulsum is like an intermediate polynomial that we say that A times B plus C minus D to the 32 plus C is and this must be 0 in order to fulfill this operation when latch is 1. So here we just define it, a state machine where we can do arithmetic operations. In this case, is this addition plus. So here you can do an addition just if, for example, setting B to 0, or you can do a subtraction by setting A and B. We'll see in the next example how we use this arithmetic circuit. So let's now build something more complex. Okay, let's build a computer. Let's build a state machine that actually execute instructions. Okay, so here we have five registers. Okay, we also have a sixth register. We call it the program counter. Actually, is the line that I'm executing. This is another register that this is in this state machine.
Ele vai pôr um contador agora. Então você tem, além dos 5 registradores, você tem um contador.
They are the instruction that I want to execute. Okay, we'll see this polynomial
instruções.
Work, but this is the instruction. Okay, we have also a freeing. Okay. And with this, we have a state machine to go from A to A prime is the next state of A. And we are evolving, we are executing. We can put any instruction that's defined by all these bits that compose the instruction, and we are executing this, okay? So let's see different instructions, how this would work, okay? Well, first, the definition would be just we define all these polynomials, okay? The same way that we saw before. Okay, we define here a set of so for this instruction must fulfill some
coisa de doutor dev, né?
We want that in A be binary, so we say that in A times in A minus 1 must be 0. Here the only condition for this to happen is that in A is either 0 or 1. Okay, we want free in to be also a 32 bits numbers. We have
não é para humanos, não é para humanos, é para robô, é para robô.
Numbers, but in this case we are at an offset just so that const can be also positive and negative.
Então, como ele está explicando tudo o que está acontecendo dentro da VM, daquela Zero Knowledge Proof VM, como são os registradores, como são feitos os cálculos, como que ele faz cálculo matemático, porque é tudo baseado em cálculo matemático, né?
Let's start with instructions that
ele está explicando tecnicamente como que a máquina virtual opera. Seres humanos não precisam saber disso. Você vai escrever seu smart contract em Solidity, vai compilar, vai jogar e o troço vai ter que executar. Ele vai pegar, transformar para PIL, vai transpilar e a máquina vai executar.
If in B is 1, then we load B, okay? We add them together.
O que ele está explicando é que como dentro da máquina virtual ele vai pegar aqueles dados que estão chegando nos registradores daquele processador virtual, da máquina virtual, e como que o processador vai trabalhar.
Okay? And we also can select the free in. Okay, and we have these set values to A, B, C, and D. So, for example, if I want to move from B to C, then in B would be 1, the other scenes would be 0, the cons would be 0, okay? And the set C would be 1, and the set A, set B, set D, and set E would be 0, okay? So in this case, this will fulfill this relationship. If I want to put a 7 in D, then cons would be 7, all in A, in D, in C, in D, in E, and in free would be 0, and the set D would be 1, and the other set
o resto 0, e vai sair o resultado do D. Tá, beleza. Vai, tio. Isso não é para humano não, cara.
We can also do conditional jumps and conditional jumps. In this case, we have a circuit. I'm not going to enter in detail how this works, but
isso sempre, PH. Sempre é muito importante. Assim, para dev avançado, entender como que ele compila, como que ele transpila e como que a máquina virtual vai operar, sem sombra de dúvidas, você otimiza melhor seu código. Sem sombra de dúvidas. Você consegue ver as operações acontecendo e você consegue otimizar o seu código entendendo o trabalho que você vai dar para a máquina virtual. No fim das contas, seu código funciona mais rápido e muitas vezes mais seguro. E funcionando mais rápido, precisou menos da máquina virtual do processamento, você vai pagar menos FII.
And how we do that, okay? And this is probably the most important slide of my presentation, okay? Because this is the trick and the main thing that we are doing here, okay? So we are connecting the last state machine, the state machine that do operations, and with the main state machine. When the main state machine, we have the instruction arithmetic. When we have this arithmetic instruction, then we are saying that the values in A, B, C, D, and the op operator must be included in the last state machine, arithmetic A, arithmetic B, arithmetic C, and So somehow what we are doing is we are connecting. We are saying in the main state machine, we are assuming that some arithmetic function is okay. Okay, so we can set up freely. We can put the values in the registers, and we are saying, okay, this condition must fulfill, and we assume that this is okay. But this is because this is delegated. The verification of this is delegated to the other state machine. Okay, and this concept of connecting different state machines with the PLOCUP, again, thank you to the Aztec people with the PLOCUP idea. This is a great thing. This allows us to connect these state machines. And this is what allows us to do engineering. We can generate like many state machines that are doing different things and connect them all together. Okay, so yeah, this would be, of course, now we have a processor. So we have a processor, then we need to define an assembly. This is a little bit how we would work the assembly. Okay, we define this from going from one register to other, and we have the arithmetic or the jumps operations. So this is an assembly. But there is something that's missing here, and it's how we guarantee, that we are executing the right program. We want to have like a ROM. We want to have a program, and we want to force that we're executing a program, because if we see here, these are free inputs. You can put any instruction that you want. This is okay. It will fulfill these relationships, but how can I create a ROM and execute this program? Okay, so let's move forward, and we create this from this assembly. We create this. Table. So we encode these instructions with bits. We have in A, in B, in C, in D, and we create what we call it a ROM. A ROM at the end is another polynomial where the first instruction, the second instruction, the third instruction, and we encode all these polynomials. Somehow this is a binary polynomials. We have the constant, constant value, which is wider the address, and we also embed the line.
Ele vai compilar
the line of the program. This is the first line, but the line 0, line 1, line 2, line 3, line 4,
a ROM
okay?
tradicional
So we have a set of values, and with
para uma ROM polinomial.
Polynomial, it's the ROM. Okay?
Para jogar isso,
para
ser executado na máquina virtual de Zero Knowledge.
We're taking all the polynomials that compose the instruction, the address, the set A, set B,
tudo isso,
jumps, arithmetic,
que ele estava falando, como faz essas correlações para pegar a state machine para arithmetic state machine é o estado polinomial.
And then we just force in the last is that int trace is included in the ROM. With this condition, we guarantee that we are executing actually a ROM. Okay, so with this we can have a ROM that executed a ROM. So we have a processor with a ROM that's executing, and all that defined with polynomial identities with this language. Okay.
Então ele converte as instruções tradicionais de assembler para uma instrução polinomial. Por isso que o Zero Knowledge Proof consegue validar, porque ele vai bater num polinômio, vai bater numa curva, e você vai precisar de alguns pontos na curva para comprovar a validade daquilo. Você não precisa tudo. Se tiver dentro da curva, tá válido. Faz sentido no final das contas. Só que é uma treta.
Fine-tuning things that will help us to implement the opcodes, but they are the same. Of course, will be many other state machines like KECAX, signature verifications, comparators. There is a lot of state machines, but with this we will create the full Ethereum virtual machine. So summarize is we have this PIL language. This is like the hardware layer. We are defining these state machines that work together. We have with this we define the state machine. We have an assembly. Okay.
Exatamente isso. Solidity vira PIL. PIL entra na State Machine. A State Machine pega aquele código ainda formal, transforma no ZK ASM para poder entrar na EVM. E aí você tem polinômios entrando na EVM. Aí você executa. É isso. Matei a charada, hein?
This is better represented in this next slide.
Ainda tô funcionando para isso um pouco. Tá dando um nó no cérebro aqui, mas tá funcionando ainda.
We have ROM. We compile that to an assembly, and this we plug it to the executor. The executor generates a Stark. Okay, with the PIL language, we generate we compose the Stark, and with the PIL language through CIRCOM and all the Stark, we generate a circuit to validate the Stark, and then this is then at the end is verified.
Volta para verificar o Solidity.
The process is very much this. Of course, the prover is not the only thing that we have to implement. The prover is just a piece of our running a full zk VM. There is also a node with all the transaction pools and so on, and of course all the smart contracts. Layer 1, layer 2 here. If you want to see how we are going to do all the transfers, layer 1 to layer 2, we have I did a presentation in ListCon, so you can find it in YouTube. You can find there, and of course we also have this. Coordinator selector. We have a new protocol. We now improve efficiency. Probably we'll have some opportunity to explain how it works, but this also what gives the centralization. But all these pieces what we are building somehow in Hermes. And the planning for Hermes, of course, this is not a full commitment. This is the project we are doing is quite challenging, but this is the schedule that we are managing internally. We are very excited. Right now we are running very fast.
Guilherme, aula de sânscrito. Vou te falar que estudei muito sânscrito lá no método de Rose, cara. Estudei muito sânscrito.
I'm sure that we are gonna,
Michael Clayton, que é instrutor, né, ainda na ativa, eu parei de dar aula há algum tempo, né?
Looking forward.
Mas o Michael ainda tá dando aula lá, cara. Tem bastante sânscrito.
But that's all my side.
Thanks so much, Jordi.
Cara, isso é animal. O cara fala, você viu o último slide do cara? Estamos substituindo transistores por polinômios. Isso é animal, cara.
I will make it copy, and everything we are doing is open source. So sometimes we are not publishing right now because we are changing very much and it's things like that.
Ele falou que vai ser open source, mas não tá publicando porque eles estão mudando muito. Mas era legal ter código publicado aí pra gente poder começar a brincar em cima disso, né?
Awesome. I think with that we are ready to move on to our panel, which is also the last discussion for today.
A temática é feia, mas é linda, pois é.
All of our panelists. This is just going to be a discussion around everything that's happened today. We're just going to
Chegamos no painel final aqui, ó. Into the ZK-verse.
Vitalik Buterin, Mihailo, Paul, Bobbin,
Vitalik, o Mihailo, o Brody, do Nightfall, que é aquele projeto que aquela mina apresentou, né, para fazer as transferências, tal, meio que funcionando. Zero Knowledge Podcast.
Hello.
Hello, hello.
Hello. Hi.
Ask everybody to turn on video, and here we go.
Everyone again.
Hi. So is everyone up?
Peraí, essa é a hora que eu vou conectar lá também.
The video's on. Mihailo.
Pô, mas minha câmera ia ficar em cima do Vitalik? Caceta.
And I think
Paul's here too.
Paul, hi.
Esse cara vocês estão de frente para um alienígena Android. É um alienígena Android de verdade.
Let's see if he can make it as well. We'll just give it one more minute. There we go. Do we have everyone? I think we're here.
Yeah!
So I guess we should kick off. I feel like we've already all been introduced. And actually, I want to share a little bit what the plan is for this panel. So we have a pretty big panel, and we have myself and Vitalik who just joined. So you have heard from a lot of the other panelists before. You've heard kind of deep dives into what they're working on. But the way I want to structure this is I kind of want to start with talking a little bit about a recent blog post that Vitalik wrote called Endgame. Then I want to bring in all the other speakers to talk about the different ZK solutions they're building, to potentially compare and contrast them or see how they're collaborating. I want to talk a bit about the ZK community, the tools that are missing, and if we have time, I want to talk about like the ZK future. So let's kick off with this, I want to say like high-level deep dive into Endgame, the blog post that you recently wrote, Vitalik. So in it, you outlined multiple paths that would give us a trustless, censorship-resistant Ethereum, but it would be scaled. And the first sort of block was very much a roadmap. And to me, that was like a roadmap without rollups. There's 4 design possibilities, 4 design changes that would help. So do you want to just explain to us a little bit what that roadmap looks like?
Sure. So that part of the post was basically actually trying to answer the question of, like, if you take
Olha lá, tô quase lá, né? O único com borda, né?
Right? Like one of these chains that tries to, you know, like have very high TPS, have not like, and completely sacrifice decentralization and have very few nodes, right? So going much further on that dimension than Ethereum was. Like, how, if you start from there, how could you turn that into something that, like, say, like I would feel comfortable building an ecosystem around?
Pronto, tô me sentindo incluído agora.
Basically, the challenge with those blockchains as they are today, right? I think I outlined it a little bit when I wrote the post on I think the limits to blockchain scalability about half a year ago, right? Where I kind of wrote that little short story of, like, you know, what happens if like 70% of the validators actually do collude and they try to.
Para de zoar que vai ter gente que vai falar que eu tô fraudando a parada para falar que eu tava no bagulho ainda.
Fully validating nodes, then like they're going to be able to actually like force that change through.
Deixa eu aqui quieto.
Users are not going to be able to do anything about it until it's too late. So the idea that I have is basically that you just add in the like elements of decentralized validation, right? And decentralized validation is something that we do know how to do. So we, like for example, we know how to you know, put the state into a Merkle tree. We know how to like put state roots after like every small bundle of transactions. We know how to make a fraud proof. We know how to make it so that if the block has even one mistake in it, then like you can make a fraud proof that covers just that one mistake, and then broadcast that fraud proof, and then the rest of the network, even if they don't have anywhere close to the computational capacity you need to actually run a full node, they would still be able to verify this fraud proof, and they would know that, hey, you know, this blockchain.
Essa é uma inovação que eu acho que é muito válida. Você não precisa ter um full node para validar o bloco e saber se ele está fraudado ou não. Isso é muito louco, cara. É o que a mina protocol está fazendo, tá? Você tem uma prova. É que aqui você tem uma prova de muitas provas que você está dando um blockchain. O mina protocol é ela sozinha. Então você, sem conhecer o restante do blockchain, você consegue comprovar toda a história. É o que o mina protocol está fazendo. Só que eles usam snarks. Era snarks? Eu acho que é snarks. Acho que não são starks. Acho que mina usa snarks. E aqui usa starks já.
Right, so my argument is that if you start with the centralized like chains of today, and you just kind of add this extra armor on top, then you know you could end up with something that's pretty decent, right? Like, you know, you solve the fraud, you solve the data availability issues, you add like some extra channels for transactions to get in that have to be included so they can't censor, and like the result is something where block production is centralized, but like all of this kind of extra protocol armor that you're adding prevents them from actually like doing anything really zero.
É o que ele está falando, a criação de blocos é centralizada, mas essa arquitetura permite que a validação seja absolutamente descentralizada. E que não é um problema você ter uma criação de bloco centralizada. Você só tem um problema nessa parte que a gente tem que pensar em bridges entre essas plataformas, né? Mas você tem uma produção de bloco centralizada para a plataforma, mas a validação não.
Sure. So I think original Bitcoin philosophy, right? Basically, like said, block production equals block validation, right? Because you know, to produce a block,
isso é fato. No Bitcoin, produção de blocos é igual a validação de blocos.
And then you make a block, and you publish the block, and then in order for someone else to verify the block, like they have to run like basically the same code, right? They have to check the signatures in the same way that you check the signatures. They have to update the state in the same way that you updated the state. They have to check the hashes in the same way that you check the hashes. Like they basically repeat what you did, right? And so there's this kind of one-to-one correspondence. It's like every unit of effort that you used in producing a block is also a unit of effort that every other node on the network has to individually take in order to validate it. And this is one of these like big bottlenecks to scalability, right? So now with some of these newer technologies, we can actually
Ele cita o Bitcoin, mas é como o Ethereum funciona, né? Um bloco, uma validação, aumenta o estado, cresce indefinidamente. No Ethereum cresce muito mais rápido.
One other technology that lets you do this is stateless clients, right? So this is the idea that whoever builds the block,
tá falando de stateless clients, clientes que não têm o estado. Você só precisa ter a última prova, validar a última prova do bloco e validar a prova do bloco.
Merkle branches proving all of the individual accounts that were actually touched by the transaction, and then they just include those Merkle proofs as part of the transaction. And someone verifying a block does not have to have the state, right? Like you do not need to have like more than like a few megabytes of RAM basically in order to verify one of these stateless blocks, because everything you need to verify the block is part of the block, right? And like the block just has this extra information telling you like, hey, Bob did have 75 coins and Joe did have 115 coins, and now Joe's going to have 90 coins and Bob's going to have 100 coins, and here's the Merkle proofs that prove that like the numbers are all correct and that they like match up with the root, right? And so if you do that, then you're already like you're making this separation, right? You're basically saying, well, if you're producing a block requires having a big hard drive, verifying a block does not require having a big hard drive, because you just verify these Merkle proofs instead, right? And then ZK snarks, they go way further, right? Just with a ZK snark, you're making production even more expensive to some extent, because you're saying if you produce a block, then you also have to do all of this extra polynomial magic with all of its overhead on top. But then
Então, é muito mais caro produzir o bloco, que tem muito mais processamento na produção do bloco, mas em compensação a verificação você não precisa ter todo o histórico. São pontos numa curva. Isso é maravilhoso.
But with these like more decentralized forms of verification, you can prevent them from doing like as much actually mean things, because like if they try pushing an invalid block through, then like guess what? They're not going to be able to make a valid proof. I see Anna disappeared, but I guess like just to kind of continue through my my post on my own a bit. So like that's kind of the principle that enables all of this, right? I think I might even say like that's the principle that enables kind of blockchain scalability theory in general. Like to me, blockchain scalability theory is all about like removing this one-to-one correspondence, right, and making verification easier than block production. So then I start talking about rollups, right? And rollups are this really fascinating layer 2 scaling strategy. Where basically you do even more separation of like basically block production and block verification, right? Because what a rollup does is it says, well, so you have the Ethereum network, and the Ethereum network has its layer 1 state. Like like Alice can have 75 ETH, Bob can have 100 ETH, and all of these the summer smart contract can have a piece of code. All of these things are just like kept track of by all the Ethereum nodes. And then with a rollup, we say, well, we have this one smart contract, and we can call it like this gateway contract. And that smart contract stores in its storage a Merkle root. And that Merkle root is, from the point of view of Ethereum, just a 32-byte hash, right? Like whatever, it's a 32-byte hash. Ethereum handles 32-byte hashes all the time. But from the point of view of its own protocol, it's the Merkle root of this whole other universe that Ethereum is not even aware of. And inside of this universe, like you can have lots of people doing their own things. Like people can have different coins. You can have even more smart contracts. And the theory is basically that to update this Merkle root, you don't actually have to like directly tell Ethereum what every single one of the transactions are. You just provide a proof, right? Because if you provide a proof,
Aqui tá falando do optimistic, né? Você não precisa falar a transação, de quem saiu, para onde saiu, para onde foi. Você só fornece para o blockchain uma prova. E essa prova pode ser de milhões de transações, e tanto faz. Vitalik bateu e cancelou o microfone. Vitalik, liga seu microfone. Alguém fala.
Vitalik, looks like you just muted. You got muted.
You accidentally muted yourself.
Ele bateu no teclado e se mutou.
So, Vitalik, I got a question for you. If you want to, since we're waiting for Anna to come back, I have a question. I saw a couple of excellent tweets the other day talking about this kind of end state.
Ele não está escutando também, pelo jeito.
Thoughtful was, in this future, is Ethereum really for blockchains? And end users are going to migrate to the layer 2s, and the future of Ethereum is blockchain to blockchain connectivity, and our multi-chain future is actually, it's all the Ethereum ecosystem. Wondering your sort of thoughts about sort of what is the future of the end user in that ecosystem?
Right. That's exactly where what I'm getting at, right? Because what you have with these rollups is, right, you have these like extra universes that get created where like the Ethereum protocol by itself is not aware of them. All it does is just verifies a few proofs. But then the rollups, like they do have all these universes, and doing things inside of these roll-up universes is much, much cheaper than doing them on Ethereum because of how it doesn't, like the entire Ethereum ecosystem doesn't have to verify all these transactions. Just the people in those rollups have to verify.
Eu vou voltar aqui pro lado original.
And so what that basically means is that you have much lower scalability, or sorry, you have much higher scalability. And you also have like much more creativity for people to do different things, right? Like you can have a rollup that runs Blossom. You can have a rollup that runs a Bitcoin like UTXO model. You can have a rollup that runs like a version of the EVM but parallelized. You can get a lot of these really cool benefits of having a multi-chain ecosystem, except with Ethereum acting as this common base layer that basically provides what we call shared security, right? So like instead of having like 100 blockchains, those 100 blockchains all talk to each other, and then if you have lots of these very interconnected applications, if even one of those blockchains get 51% attacks, then that might like risk the entire network. You just say, well, no, all of these 100 things are rollups. They all like live on Ethereum. And when they all derive security from the Ethereum base layer, the Ethereum data availability layer, and all of these things. And so in order to make any single one of them break, you basically have to make Ethereum break, right? And like so this kind of like shared root of trust and shared root of bridging, like it allows for cross roll-up communication to be really efficient. It allows for shared security. You have all these.
É que sintetizando o que ele está falando é utilizar o Ethereum como blockchain de checkpoint para os outros blockchains. Só que esse checkpoint ele registra provas, né? E com um pouquinho mais de inteligência para você poder reverter esses blocos. Mas é reduzir muito o potencial do Ethereum e colocar todo o restante do potencial em redes paralelas, em múltiplas redes paralelas, trabalhando, conectadas no Ethereum e cada uma fazendo uma coisa. Aí eles vão falar que o Ethereum faz milhões de transações por segundo, quando na verdade são diversas redes diferentes, tecnologias diferentes que até podem ter uma interoperabilidade, mas que estão utilizando o Ethereum apenas para fazer a segurança como um base layer. E isso poderia ser o Bitcoin, cara. E que acredito que vai ser o Bitcoin no futuro, com uma camada com um pouco mais de inteligência. A gente já tem aí aquela stacking, o stacks, fazendo isso com o Bitcoin já, e várias outras redes fazendo isso no Bitcoin, né? O Ethereum fez tudo aquilo para voltar a ser o que o Bitcoin está fazendo. É um pouco mais, é diferente, a tecnologia é diferente, mas na essência, se a gente simplificar a essência, é o que o Bitcoin está fazendo e que os caras sempre condenaram, sempre condenaram.
You mean by the ZK rollups in general, like these architecture?
Just basically, yeah, it's like investing into ZK for scaling. Do you think that's purely for scaling, or do you think it opens up new possibilities?
Definitely. Yeah, that's a fantastic question. Yeah, thanks so much, Anna. But we believe ZK-based solutions have much wider, basically, area of application than scaling specifically.
Vitalik digitando enquanto tá rolando a apresentação, vai ficar pulando a tela dele. Parece que ele tá pulando, né? Eu já vou soltar o galo doido. O galo pira. É, porque pra gente é galo pira.
Global Internet of Value and Web3, and we really have this pressing need to welcome these people and allow them to experiment with Ethereum, basically. So once, ideally, I foresee maybe in 1 to 2 years, we will have some solutions in place that will be scalable, much more scalable than those that we have today, and that will have security properties of Ethereum, and that pressing need to scale will be kind of relieved. Then I believe we will see other interesting and amazing applications of ZK technology, primarily on the side of privacy, related to identity, for example, and many really other interesting applications. That is at least my opinion, or my bet for the future.
Very cool. I want to ask a question to Jordi and Brendan, actually. So the two of you have proposed uniquely the ZK EVMs, and I've been very curious about kind of how those are similar or different. Like, I know you're working together in a lot of ways, but could we explore that a little bit? What a ZK EVM, maybe also just define what that actually means and how those two solutions are potentially a little different. Go ahead, Jordi.
I can start. It's there are, I think there are two projects that they are started in different point and probably with different goals and with different environments, and we were independent. None of us were at Quiet for Polygon when we started the project, and we come from different places, and I think we have good things and things that maybe other teams are better, and they have good things and maybe things that we can go better. And the good thing of being, in this case, together in the same umbrella of Polygon is that we have this collaboration relationship. And right now I understand much better what they are doing, and they probably understand much better what we are doing, and we can collaborate and help one each other. Actually, I would like this to be even opener, not just to the Polygon projects, just to wider projects, and because we are solving, it's a humanity challenge. You know, it's not, it's something that we need to solve. If we want to blockchains to scale, we need to somehow work together. And totally. and for us, you know, these are, there is nobody that holds like all the knowledge for building this. And as much knowledge we can join together in order to scale this, we will do it faster and better. And this is a little bit the spirit. Of course, collaborating teams is not easy, but you know, we are just starting. You know, it's just the beginning. But the feeling is that we are sharing the same goals. We come from different places. We have different knowledge, but we are sharing the same goals. And I'm sure that we will work every time closer and better.
Nice. Yeah, Brendan, do you have any thoughts on that? I mean, I think, Jordi, you just shared sort of the similarities. I mean, the use of Fry, or the use of Fry-like techniques in both are a similarity there that I noticed from the presentation that Brendan did earlier. But Brendan, yeah, maybe do you want to share a little bit about the way you're thinking about it?
Yeah, sure. I think just to echo what Jordi said, it's been really great working with Hermes and with Biden, and I feel like we've sort of created the foundation for something really special moving forward. I think that the way that we see it, I think I don't want to speak for Jordi, but I think what they're working on is super cool, like sort of simulating the EVM kind of opcode for opcode or close to that in a snark is like an amazing goal. For us, like our ambitions might be a little bit more modest. Our goal is we'd like to be able to take existing Solidity code and transpile it into what we call ZK bytecode, maybe swapping out some things that are really expensive in a snark like SHA-3 for more arithmetic friendly hash functions. And yeah, just trying to build something that's very performant and can scale. So that's how I'd sort of characterize both. Like it's just great to be able to work within Polygon and to kind of explore the whole design space and collaborate. And yeah.
I actually want to bring in Bob in a little bit on the conversation now, because I mean, that use, you talk about the collaboration, and then you're using Fry, which originally came from Starks. Bobbin, you're building a Stark-based rollup. Do you want to tell us a little bit about, I don't know, maybe we can talk a little bit about the connection or what you're getting from some of this dialogue. Oh, you're muted, by the way.
Sorry about that. Yeah, so I think in terms of collaboration, there is a lot of I think there are some similarities with both projects that kind of we think about in many different technical areas. One example that I kind of talked about in my presentation is that because, for example, Starks are very flexible, and Fry allows you to be flexible in terms of choosing the finite field you're in. Maiden is actually using the same finite field as Polygon 0 is using, so we have abilities to kind of jointly work on different things that might be useful in that specific field, and use it will be used in both projects, and that's in terms of optimizations and in terms of developing arithmetizations for specific problems that either they come up with and I can use, or I come up with and they can use, and that works very well. And there are other decision points, in terms of how do you overall, I think there are three big buckets of choices when you kind of think about these solutions. And the first bucket is what proving system you use and what arithmetization you use. And then the other bucket is kind of what is the design of your virtual machine. For example, are you gonna which field are you going to choose? What is going to be your instruction set? Is it going to be very close to the EVM or as close as possible, or is it going to be slightly different and then you're going to transpile? And the third design choice that you need to make is what your network architecture is going to look like. And there are different with Hermes, we might look more into their network architecture of how they're thinking about, and try to have some of the learnings from there to apply to Maiden. But in a proving system aspect, we might be more close to what Polygon 0 is doing, and so we might take some learnings from there. So there is a lot of different areas to kind of collaborate and cross-pollinate knowledge across.
I feel like your conversations are probably incredibly interesting. I hope you document some of this for others, because just thinking, and actually, yeah, what are the plans for how to share information within the org and also outside of it?
I think one of the things I want to say, the conversations that we have is probably a highlight of my week. I have to wake up a little bit earlier than I usually would like to, but it is a highlight of my week when we just basically chat for a few hours about the things that we've done over the last week and what we are planning to do, and what problems everybody's facing, and what solutions we have found. So it's really cool.
I can only second what Bobin said, and it's really one of the things. Of course, we are really proud that we have all these amazing people and these amazing projects now under the Polygon umbrella. But what we are really proud of, and what is really exciting, is to see actually these teams working together. It's very clear spirit of collaboration, not even mentioning or even thought about one team being competitor to each other or something like that. And we really are aware that this is early stage of innovation, and it's really amazing and inspiring to watch these teams basically on these calls, discussing, exchanging knowledge, updating each other. It's really amazing. And exactly as Jordi said, we would really like to be, we don't want to be a closed source, ZK powerhouse, or something that is not shared with the public. We want to include all other relevant projects, individuals. We are still discussing and thinking about ways how we can make this more open to the general community and to everyone basically that are interested in scaling Ethereum in this way.
Cool. Well, I like to hear that. Paul, I want to ask you about your solution. So when I heard about Nightfall, it this idea of mixing optimistic rollups with ZK rollups. Yeah, tell me a little bit about when that kind of came to fruition. What was the why did you decide to actually add the optimistic to this?
So, I mean, we've been working on privacy for 5-6 years now. We actually showed the first version of Nightfall in 2018 at DevCon in Prague. And we've been cranking out that we cut the gas fees, we implemented, simplified all of the data sources. We ended up with batching, and you're just in an endless race with how you kind of drive down the gas fees and the cost structure to make it affordable. So, if you talk to enterprises, there's a couple of things that they really care about. Number one, right, they really want to have privacy. Like, enterprises will not do anything. If I'm going to move my inventory or buy stuff from another company, that's sensitive business information, how many widgets I'm buying, who I'm selling them to, how much I'm paying for them. That is incredibly sensitive. They will not do anything without privacy. That's like job one. And then the other issue is, and this comes up all the time with enterprises, and I'm worried about the gas fees. Are the gas fees going to be unreliable? Is it going to be too high, right? They understand that they want some predictability in their cost structure. So back at the beginning of this year, we were looking at sort of where to go next, and we realized like optimistic rollups give us this excellent combination of kind of speed, cost, and privacy. And so Nightfall 3 became an optimistic rollup. And then we're working with Polygon, we're able to turn it into Polygon Nightfall and add things like instant withdrawal that we showed earlier today.
Very cool. And that focus on privacy, I actually kind of like, we mentioned this sort of like maybe with the scaling comes privacy, but to the other three teams here, Bobbin, Jordi, and Brendan, is that very, like how close on the roadmap is privacy for each of you? Like, is that built in or is that kind of coming later?
I can try to take this. Oh, go ahead.
Okay.
I was just going to say very quickly, like we're, the level of cooperation that you were talking about inside of Polygon across those teams, that has also been applied to the relationship with EY, and the level of cooperation is astonishing. I mean, so many brilliant people like Brendan and Bobbin, and there's Mihailo is coordinating a lot of that. So I will say we're not going to silo the privacy knowledge in one place.
I wouldn't imagine that. It sounds like that would be very off-brand. Cool. Okay, Bobbin, yeah, you were about to say something about that.
I do want to say that, like, even though the scaling is the primary goal, and but I do think, like, for me personally, privacy is also almost as important as scaling, although we need to prioritize scaling right now. But I do think, like, when I think about like the design of the virtual machine is like how can we support privacy, or design of the network itself, the rollup, how can we support privacy in the future? And I do make sometimes very conscious design choices, which may not be necessarily ideal for supporting scaling, although it's not going to hurt it too much, but they will make supporting privacy or privacy preserving smart contracts much easier in the future. So it is very much front and center for me.
Cool. Jordi, Brendan?
Yeah, it's part, of course, it's part of the roadmap. Of course, it's not like the first priority that we have right now. As Bobbin says, I think we need to solve right now. The first is to scale, but immediately next is privacy, and this is of course important. And yeah, maybe Brandon can add some value here, but I think that the recursive snarks is a key piece for privacy at some point. So maybe Brandon, you can add some points there.
Yeah, I think just like you said, I think for us, one of the obviously
a preocupação primária deles é a escalabilidade. Privacidade está em segundo plano.
Provers is and sort of focusing on commodity hardware for provers is that for applications that require proofs to be generated on the client side, we can do that like very, very quickly. And so our prover performance sort of makes transaction creation feel like instantaneous for a private transaction, whereas before, if you were creating a proof for a more complicated or like general smart contract, it could take like 30 or 40 seconds with previous primitives. And so that's something that we're excited about. But like Bobbin and Jordi said, we're sort of focused on scaling for the short term.
Cool. And Paul, I have one last question on your project, which is like, I know the project ZK Opru, which is also a ZK rollup, optimistic rollup combined. How do you see yourselves as different from that or similar?
So we looked across, when we started out some of our work and thinking about optimistic rollups, we looked across all the layer 2s, right? There, of which we sort of counted up 12, right? 4 of them are focused on privacy. ZK Opru is next to ours in terms of snark usage, one of the most efficient. I think where we see kind of a really important difference beyond the integration, the work with Polygon is
como esse cara está fazendo uma plataforma que utiliza ZK Rollups e Optimistic Rollups ao mesmo tempo, consegue comparar a diferença de performance dos dois, né, e custos também.
So there's no complications, there's no friction. You don't have to sit there and go through the license terms and think, is there a gotcha or a surprise here? It is a pure, unrestricted contribution to the Ethereum ecosystem. And there's no surprises, there's no monetization model in there. I realize I'm not going to make myself CEO of the year with this speech, but it really, we wanted to drive adoption and making contributions to the community. And this is where we kind of made our stand. And in working with Polygon, we found people who were like, yeah, that's a good idea. And that made a big difference.
That actually, like the next topic I want to touch on are the tools that are missing. And I feel like this kind of open source ethos, like let's think of it in that context. So very, very usable, very open source. What are the tools that maybe the Polygon teams or Polygon affiliated teams or maybe outside teams should be thinking about building in the ZK space? I know that's pretty general, but I'd love to hear from all of you what you're thinking about this.
Sure. Yeah, thanks, Anna, for the question. And I think, of course, the question is very important. And there's like several ways or several things that we're doing in that regard. So first of all, with all the teams are pursuing this Ethereum compatibility in one way or another, either we're implementing the EVM itself or introducing compilers that will support Solidity, etc. And that is already we're doing a huge service to ourselves. First of all, like we're benefiting from everything that has been created in the Ethereum ecosystem. So all the toolings from wallets to block explorers to all those very important toolings. And we are very much aware, building Polygon and Polygon POS chain example and Plasma before that, we are very aware of this big difference. Once you build a solution that is not Ethereum compatible or EVM compatible, like we did with Plasma initially, and once you have an EVM compatible solution, it's like a huge difference. So you instantly are in a much better position because you just simply can inherit, relatively easily, you can inherit all the existing toolings of Ethereum. That's number one. Number two, we are fortunate that we have now multiple ZK-based effort or ZK rollups specifically within the Polygon ecosystem. And we are already starting an internal effort to kind of introduce some standards because there are a lot of components and tools that will be shared between these solutions. So the core, I guess, engines or virtual machines of these solutions are quite different, I would say. But the other components are relatively similar and there's a lot of overlap there. And moreover, there's overlap with the existing POS chain, there's overlap with the stack of our Polygon SDK, a solution, another solution that we have. And we are currently establishing these standards and we believe this will significantly speed up the development and make the solution all the solutions at the same time more bulletproof in a sense that all of them will use the components. So there will be the same components. So they will be much more battle tested and I guess secure. The third thing that we intend to do is that we, as I said earlier on the panel, we have this 1 billion, which is pretty significant commitment to develop these types of solutions. We will be offering extensively grants and publishing constantly missing components or tools that are required for the ecosystem in general, not only for Polygon, of course. And these are at least 3 things that immediately come to mind when it comes to building or introducing all the missing components. So yeah, I'll leave it to others.
Yeah, that question of which tools, this has actually come up recently. We're doing a Gitcoin side round, just FYI, all focused on ZK tech. And one of the thoughts that we had around that was like, what does the community actually need in terms of ZK and how is that communicated outward? Like, I'd love to find ways, maybe together with the Polygon team, to like gather some of those tools and share them to the larger community so that like we can find those teams to potentially build them. I kind of want to throw to Vitalik again about this. Like, from your perspective, maybe it's not exactly tools, but what pieces do you feel need to be implemented for some of those futures you outlined earlier in this?
What kinds of tools needs to be implemented? Let's see. I think again, like first of all, the Ethereum layer 1 needs to be improved. Obviously, like we need to actually finish up with the proof of stake. We need to execute on the sharding roadmap and like actually add more data space so that rollups have some place where they can put data on. Like about a week ago, I released to this post. It was the data sharding roadmap where I talked about how to like split it up into different stages where like just adding more, like reducing the gas cost of call data would be the first step, and then you would add like a shard or like a couple of shards to just add a bit of data space. And
até porque se ele não escalar e não baixar o fee, essas soluções todas vão continuar bizarras, né? Porque você que é pequeno, você não consegue nem entrar na solução e nem sair dela. E se entrar, você não sai com o seu token, com o seu recurso.
Several megabytes a second worth of data space that rollups could just really use, and that by itself is already enough to just give a huge amount of scalability for rollups. But in order to get there, that stuff has to actually be built, right?
Yeah.
So that's one piece. And I think ZK EVM implementations, we talked about them a lot, but also just like very important in the very general purpose infrastructure. I think one other thing also that I think doesn't get talked about with ZK EVM implementations is that they have two purposes. One of them is that they enable fully EVM compatible ZK rollups, and the other is that they enable better light clients of the Ethereum chain, right? Because the Ethereum chain itself, like we would love to snark it, we would love to make it so that you don't need like as much of a heavy node in order to be able to process and like verify things that are on the Ethereum chain. So if that itself gets us snarks, then that's also something that's going to be amazing. Sure.
No, go ahead.
Number three, cross rollup bridging infrastructure. Just if we're going to have like a layer 2 world in general, like that's can't be avoided. Like I've written some posts on
o que ele chama de cross rollup é a interoperabilidade, né? Precisa ter interoperabilidade entre esses caras todos.
A bunch of different versions of ways to do that. So really excited to see that space mature more.
Very cool.
And then user experience stuff. Yeah, okay, fine.
E melhorar o user experience.
No, keep going. If you have another one.
I really am done.
Okay. Well, you just mentioned actually bridging, and I want to understand, like, as we imagine more and more rollups coming out, all having these different forms. Mihailo, you talked about standards, but what is like, and maybe it's too early at this point, but like, are you all thinking about the bridges between your different potential rollups? And is this something that you already see on the horizon? Is this a problem you're going to get to later? I'm just curious.
Falamos disso, hein?
Yeah, great question. And I just might use the word standard. The word standards is, we're being very cautious with that word at Polygon at this point. Like, we don't want to impose any sort of constraints. We believe this is a phase really of high intensity innovation and experimentation within the Ethereum community in general, including Polygon, of course. And hence why we do not want to impose any final, global architecture or ways or standards how these applications or projects will communicate among themselves. We really want things to happen organically. We see a lot of collaboration between these
nesse ponto eu concordo com ele, né? Não dá para impor nenhum standard para uma coisa que não está finalizada. Você não tem os rollups 100% rodando ainda. Como você vai pensar em interoperabilidade de rollups se o rollup não está pronto? Você pode limitar o protocolo antes dele ter sido finalizado.
Using components in a helpful way. But that being said, moving forward in the future, like Vitalik, as he mentioned, he had a very interesting idea how to bridge these rollups in a trustless manner. And we are willing to explore. We just want to explore and facilitate as much innovation as possible. We believe Polygon is a very good position now in terms of resources, reach, network effects, and everything. And all of that was, or pretty much all, was enabled by Ethereum, basically. So we owe Ethereum community and Ethereum layer 1 a lot. So I think this is now the perfect time for us to start giving back, actually.
Cool. Yeah. I want to kind of imagine, like, I think we're at the stage where we can start sort of also like imagining the future of ZK. What could be coming down the line? So, we've talked about this the private rollups. Often it's like private transaction within the rollup. But when you start offering something like private computation, I'm kind of curious, like what do things living in a non-private and a private actually, like is there any envisionment on how these would interact? And I don't know, Vitalik, if you're thinking about like what a privacy, it's a roll up. In Cosmos, you call it a privacy zone, but like what kind of thing, what does a fully private roll up with potentially private computation actually mean?
Yeah, I think privacy preserving smart contracts infrastructure is, it's a really big, it's a really big and exciting field all on its own. I think like one thing is that there is no magic bullet, right? I think, and like there is no magic, like, and that's more true for privacy.
Coisa manda lá no Discord,
scaling, right?
Jeff.
Like for scaling, you can't say that there is a magic bullet.
A gente checa, a gente dá uma olhada depois. Manda lá no Discord qualquer coisa. Faz uma força-tarefa aí e descobre qual é que é.
Like that you have to start thinking like much more explicitly about, well, like who actually gets to have each piece of data, right? Because in order to make an update with a piece of data, you need to have a piece of data. And so you can't have, literal black boxes where nobody sees anything. You have to have data. That data has encryption keys, and there's some people see each of these encryption keys. And so like you have to think explicitly about like who are the owners of things in a privacy preserving system that you don't have to think about in just like an EVM system. And so like you are going to have to like work hard on programming languages in a way that you don't if all you're doing is just copying Solidity. You have to like actually think hard about like what applications are possible. Do applications even need to be redesigned? Like, is privacy preserving Uniswap something that's even possible? Right? Like, who would even have the encryption keys to the EM app? Or do you have to design it in a totally different way? So it's this big field, and I think it is going to take quite a bit of learning. I expect we're going to start with the simple stuff, like just being able to move coins around, and then people are going to build more and more, and we'll see what happens.
That idea of the private AMMs, and this is a topic I've covered a couple times on the show. I wonder if the roll-up builders, are the roll-up builders working closely with the AMM builders on that front? Like, is there a strong connection between those two communities? Paul, I don't know if you have any thoughts on that.
So I don't know if there's a strong connection, but I do want to, there's a couple of very specific things that we are working on that I think are relevant, and you could make a private AMM. One is we're building something called Starlight. And the idea behind Starlight is, what you can do is you can mark up the logic.
Estou falando dos, é que o tradutor aqui é horrível, mas ele está falando do Automated Market Makers. É a treta como que os robôs de arbitragem vão funcionar dentro desses circuitos utilizando Zero Knowledge Proof. Isso é um baita desafio. Pô, cara, vamos primeiro colocar o sistema no ar, mas aí a gente vai ver como que vai funcionar o Automated Market Maker. É importante, né, pensar nos MMs.
Zero knowledge circuit coming out of that, so you can have logic that runs on chain. And the reason you want logic to run on chain with privacy and not just do it off chain and post a proof is a lot of business processes between companies. There are multiple participants, right? If you have a network level business problem, you can't have an individual participant successfully solve that for all the other network participants behind their firewall in their ERP system. Right now, they can see too much confidential information from all the others. So this is something that's super important. And then the other thing is we're working on something called Midnight. The goal is to make all the transactions look the same. Right now, you can still look at, oh, he made a deposit, she made a withdrawal. We want to basically really make things are even darker and make it harder to do network traffic analysis on who's doing business with whom.
Got it. Cool. Jordi, I have a quick question for you. I don't know if have you spoken with any of the AMM builders, any of the DeFi folks. I'm just so curious if there's if there isn't yet a crew doing that, we should start bringing you together.
I've been talking with some of them, but not in the roll-up context. I've been talking for auditing the smart contracts and formal verifications and other stuff that are very interesting. And they are
difícil, né? Você tem que considerar a existência dos automated market makers hoje por causa do caminho do DeFi. O que ela está querendo perguntar, na verdade, é: vocês estão construindo uma camada aí de segurança, de privacidade, de escalabilidade e tal, mas vocês estão falando com os caras do DeFi? Vocês estão falando com os caras do DeFi para ver se o DeFi vai rodar aí? Na minha opinião, é privacidade primeiro, depois você encontra um jeito, se der, para construir essa coisa em cima. Né? Porque para o Automated Market Maker, ele precisa saber o que está acontecendo para poder fazer, por exemplo, um trade. Ele tem que ver qual é o trade que está acontecendo para poder ver a oportunidade, né? E provavelmente a gente fala em Zero Knowledge Proof, fica mais difícil. E como que você abre? Você vai deixar a porta aberta para esse cara? Mas tem que conversar, mesmo que seja para botar um balde de água fria, mas tem que conversar. Mas eu prefiro, na minha opinião, né? Eu prefiro primeiro falar de privacidade e depois o outro. Porque basicamente quando eu falo Automated Market Maker o que vocês estão construindo? Vai acabar ou bloquear esse farm infinito, desse loop infinito de liquidity staking que a galera tá fazendo nas liquidity pools, de pega de uma, coloca na outra, que coloca na outra, coloca na outra, coloca na outra, e gera esse ciclo infinito, esse moto perpétuo de geração de moedas. Isso vai atrapalhar o que está sendo feito? É isso, ela quer saber se dá para continuar ganhando dinheiro infinito nessa máquina de dinheiro infinito que não faz sentido muitas vezes acontecer, né?
Zero knowledge proofs for anti-DOS, anti-spam purposes. So the idea of that, you can prove that you have some token and without actually proving which particular one of those people you are. I think that's something that can be used to protect decentralized messengers status, for example, against DOS attacks. If the token that you're zero knowledge proving is a proof of humanity token, then you can have things like UBIs and things like civil resistance in a way that's friendly to people who don't have lots of money, without having to actually create on-chain mappings between transactions and people's literal faces. So I think that's something that can be huge.
Yeah, I know. And what you just made me think of is an example that comes more from the financial, which is whitelisting using ZKPs. But actually, that idea could be used also just for accessing groups or knowing that certain tokens are in somewhere without knowing anything more about that account or that user. It's very. I mean, there's some really cool identity groups, group management. Yeah, I don't know. This is an exciting space.
So what about things?
Go ahead.
Yeah, as Vitalik said, I think more or less all of these use cases go back to either scaling or privacy in one way or another, basically. But there's really so many interesting or really necessary applications.
Legal. Bom, a gente sabe já que Zero Knowledge Proof para messaging, acesso a grupos, controle de acesso é muito legal.
Capital and almost bought the US Constitution, and that's just one example where you really need privacy, because if that pooling of capital was private, then the opposing side or other bidders wouldn't be able to know how much Constitution DAO is actually willing to bid, and they wouldn't be able to kind of somewhat trivially outbid them, because you just simply know the amount of capital that the bidder has at disposal. So
vai ter exemplo da Constituição, ter uma leilões Zero Knowledge Proof, porque você, é tipo aqueles leilões de carta fechada, sabe? De envelope fechado. Dá para fazer leilão digital de envelope fechado com Zero Knowledge Proof. Você vai para um leilão, não tem como o cara dar um bid maior que o seu, porque sabe qual bid que você está dando, esse leilão tradicional. Você faz um leilão de carta, leilão de envelope fechado, né? O cara vai lá, anota, entrega o envelope, abre-se o envelope e sabe-se que tem que o cara deu o bid. E melhor ainda, sabe que deu o bid e que ele tem o dinheiro para pagar. E você não precisa nem saber quem foi. Você só entrega. E não importa a identidade da pessoa, né? Muito legal o leilão de Zero Knowledge. Vai sim, Thomas. Vai ficar gravada, vai pro YouTube depois. Tá?
Anyone? We can just leave that there. Games and ZK, it's a thing. Check it out. I don't know.
I haven't seen anything, but I think once building ZKP focused applications and if it's easier to do with virtual machines or with compilers or whatever, once it becomes very
Cara, no futuro, ela fez uma brincadeira perguntando sobre games e ZK e Zero Knowledge, né? O pessoal ninguém quis responder. Mas é que, na verdade, a gente vai ter num futuro esse tipo de coisa rodando tão naturalmente que vai ser tudo construído em cima de Zero Knowledge.
ZKP functionality built in.
Very cool. In general, actually, do you see the Polygon ZK fund, this pool? This is meant, I'm assuming, for a lot of tools.
Quando você vê, foi o vilão do filme que comprou.
Scaling solutions, libraries. But do you think that those applications that live on top, but really, really deeply use ZK would also potentially fall under that category?
Absolutely. Also funding important research activities and everything that is directly or indirectly related to building or adoption of ZK-based scaling solutions and privacy-focused solutions. Everything falls under the scope, I guess, of this fund. Definitely. And that's why, for us, it was really a huge commitment. As I said, in the beginning of the event, we are fortunate enough that our treasury is very strong now, but even for us, this was a huge commitment from our side, and it just basically maybe manifests our belief how important this technology really is for the whole ecosystem, for the whole industry, and that's why we decided to commit this significant amount and really help, again, everything that is indirectly or directly related to either research, development, or adoption of this technology.
That's awesome.
And I want to mention, just to piggyback on Mikhailo was said, is that we're trying to do a couple of fundamental research type of things where we try to figure out and engage researchers even outside of Polygon to figure out how we can, for example, speed up arithmetization-friendly hash functions even more once we have specific constraints of, we're going to use this field. Can we do something much more kind of performant in that specific field rather than trying to build a arithmetization-friendly hash function in general? So there are a couple of projects that we're trying to do just even in the foundational research type of area.
Fantastic. I think we may be at time. Kartik, are we?
If there's any closing questions, we can go with that, but we're at time.
Okay. Well, yeah, if there's anything that anyone here wants to mention before we sign off. Anyone?
Nothing. My side,
ZK is exciting. Join us, maybe.
Just reiterate on that I previously said that I'm really personally as
Nossa, os caras deixaram a mina no vácuo a galera tá querendo vazar, mano. Né? Nas duas últimas, né? A galera quer vazar muito. Nossa, cara, tadinha. F pra ela.
And again, a responsibility, but we are really committed and again, grateful for all the support, and we are really just starting. Expect a lot of great things.
Cara, é um ponto muito inicial mesmo, viu?
Cool.
Daí é uma coisa legal para postar umas fichas.
Well, I guess that wraps us up then. Good luck, everyone, and we can't wait to see what happens in the Polygon ZK world.
Thanks a lot, everyone. Thanks, Anna.
Yeah.
Thanks, everyone.
Thank you, everyone.
And thank you so much, Anna, for moderating. And I think we are ready for a close. And one thing I just want to say is I want to just thank everybody for tuning in and watching this whole thing, because what we're talking about, what we're doing now is what's going to be the standard a few years from now. And that to me is the most exciting piece. Like you're seeing a sneak peek at what the future looks like in different pieces, and just kind of, it's just the same quote around the future's already here, just not evenly distributed. And we're just seeing a glimpse of what's to come. So thanks everybody for sharing everything that's happening in this entire ecosystem. It's not even just Polygon, but all together, Ethereum and Zero Knowledge and Snarks and Starks. And can't wait to see what comes out of all this that benefits everybody.
And huge thanks to you, Kartik, and your whole team for facilitating.
Eu acho que não dá para simplificar, não. Tuco. Eu acho que é mais complexo que isso.
So thank you so much. And with that,
o problema do Ethereum é outro.
Congrats on everybody who
a
stayed
forma
till the
como foi
end
arquitetado,
and
tal,
see
tem
what's
outras
happening in this
questões.
entire ecosystem.
Pode falar na sequência.
ZK Day for us, and for those of you who are wondering, and I know that I'm going to get this question the most in the next minute, we will be sending the POAP tokens to everybody via email directly. So don't worry, you'll get that email directly into your inbox if you signed in. And stay tuned for more things to come from the global site. We'll be very soon sharing what 2022 looks like for all of us. And hope all of you enjoy the weekend and see you all in the next year. Take care, everybody.
Take care. Bom, né? Caraca. Muito bom, cara. Eu curti. É um tema que eu gosto, eu curto. Então, o que o Tuco perguntou ali, ó. Dá pra simplificar o problema do Ethereum. É que os incentivos são para a funcionando. Não são.
Bitcoin?
Não são.
O que é isso? Criptomoeda?
Você não tem incentivo para manter a VM funcionando. É diferente. Né? A VM é como o Bitcoin. Você roda, não é que nem Oh, caramba. Um masternode. Não é um masternode, né? Ele passa a ser masternode agora com o Ethereum 2. Então você tem um nó completo, você tem que gastar do seu bolso. Então, se você não tiver um outro meio de... E é uma máquina cara, não é uma máquina barata, não. E você vai deixar essa máquina... Não vai rodar fácil aí num Raspberry Pi. Não vai rodar num Pi. Você precisa gastar aí num equipamento. Precisa de um armazenamento grande, fazer um node de archive, mano, é muito, puta, é muito tera, cara, é muito tera, né? Então, assim, tá caro, tá difícil, então não tem um incentivo. O problema do Ethereum, na verdade, é que tem uma especulação maluca em cima de uma coisa que foi criada, emitida quase que infinitamente, com um hype gigante, e aí começaram a surgir grandes projetos que começaram a competir por espaço no bloco. Os mineradores começaram a escolher o que ia para o bloco, a galera começou a fazer leilão de FII, e o valor foi subindo. Consequentemente, o valor foi subindo. Então tem um mercado que tem muita manipulação, tem um grupo muito... a forma de governança dela ainda é bagunçada, né? Por mais que tenha uma organização X, a gente sabe que muitas coisas elas são meio que impostas. Então é diferente, não dá para falar que uma coisa equivale a outra, né? Até porque se pensa só puramente no nó, você não ganha nada para rodar um nó. Não ganha nada para manter a VM funcionando. Nada. Absolutamente. Né? E provavelmente, por exemplo, para rodar uma Polygon, uma VM dessas, também não vai ganhar nada para isso. Você vai ganhar num stake e um nó de validação, provavelmente. Você vai começar a ganhar agora, né? Então são diferentes. Ó, o Kiko chegou aí, né? Pegou o badge também, mandou um galupira, né? Então é isso, galera. Eu acho que valeu, né? Valeu, ZKD, Zero Knowledge Proof na cabeça. Vocês viram que o tiozão cringe aqui não tá tão ruim não, né? De conseguir ler tudo que os caras estavam colocando lá, interpretar e ainda mandar a resposta antes do cara apresentar. Mandei bem nessa aí, eu tô até orgulhoso de mim mesmo. Tô até orgulhoso, né? De vez em quando eu acerto uma. Às vezes eu acerto uma, né? Às vezes eu acerto uma. Mas é isso então, ó. Amanhã, aqui já são 9h45, eu preciso ainda, tenho coisa pra fazer. Então, galera, fico por aqui. Amanhã temos nosso encontro, ó. Temos nosso encontro logo cedo, às 8 da manhã. Tem sorteio da Ledger, amanhã. Tem um monte de coisa. O Guiço falou que vai patrocinar um NFT, vamos ver, né? Guiço prometeu, vamos cobrar ele. O bloco, o papel do chat é cobrar os caras que prometem drop, né? Vocês têm um compromisso, é do chat, não sou eu, né? O chat tem esse compromisso de ficar cobrando a galera que fala as coisas no chat. Então, né? Então é isso, galera. Eu fico por aqui. Vou terminar minhas tralhas aqui, fechar as coisas. Deu tudo certo com a live. Vocês viram que ontem a live morreu, mas foi por causa da pane que aconteceu na Amazon, né? Antes de ontem, né? Isso na Amazon, agora tudo normal de novo, o sistema aqui tá funcionando. Fora a minha teclinha aqui, que a pessoa ficou de mandar minhas teclas do teclado que quebrou aqui, mas vou esperando chegar pelo correio. Vai chegar antes de ontem. Eu tô fora do tempo, eu não sei mais. Eu tô indo dormir no meio da madrugada, acordando muito cedo e tô ficando doidão. Já não sei mais que dia que é hoje. Só sei que amanhã é dia de sorteio. Episódio 136.1. Até esqueci de atualizar, né? Mas fica aí como complemento, na chamada aí do título da live, tá 136.1 já. E eu esqueci de mudar aqui que eu abri correndo. Tinha dado pau na Twitch e tudo, aí eu abri correndo. Então é isso, galera. Novamente, se cuidem. Lembre-se que estamos numa pandemia. Juízo com seus investimentos. A gente se vê amanhã de manhã com um episódio especial, sorteio da Ledger. Sorteio de mais uma Ledger, né? Até mais. Agradeço pra galera que ficou até essa hora. Tamo junto, galera. Amanhã cedo a gente se vê. Falou e tchau.
Bitcoin, o que é isso? Criptomoeda.